Good afternoon, my dear J26 warriors. It's time for marathon and a long marathon. And we kickstart this Christmas holidays with these long marathons, which are going to be fully power packed and boost your confidence, your problem solving skills, your concepts with all the tips, tricks, covering every single model of question which is sure shot going to be asked in your 2026 exam. Today, we are going to take the entire unit of modern physics right from photons, photoelectric effect, wave particle duality, then we'll take a break, then we'll have atomic structure and atomic spectra and collisions, then we'll take a break, and then we'll go to nucleus and semiconductors, and then obviously logic gates, right? So that is the flow of today's class. That's what we have planned. So entire modern physics units will easily give you around 20 marks to 24 marks, and in certain shifts up to 28 marks. So easily 7 questions can be asked in certain shifts, but bare minimum you can expect 5 questions in total, from all these topics combined together. So power packed 123 questions of modern physics with your captain Shreyas, your physics master teacher. I've been training, guiding, mentoring, teaching for a long time, more than 13 plus years. And kids just like you, I have made sure that even an average student has gathered that knowledge, has gathered that confidence to enter a top tier college. And I'm really proud that when I meet students, even when I'm walking somewhere, and they come and say to me, "Sir, I have been watching your YouTube classes. I have been in your batch. I have, followed you ever since this. And, right now I'm in this NIT, I'm in this IIT." So it feels extremely, extremely good. And I'm pretty sure you too are going to do the same. So with this, make sure you're marking your attendance. Yep, down in the description box of this video. Yeah, do that right away, right now. Yeah, I hope I'm audible and visible. Smash that like button. Yes, and remember, after the session is over, you can ask Ved any doubts. So, for example, once that session is over, you can ask Ved doubt on how to solve this question. How do I do this? Can you give me more questions on that? Everything Ved will do. So you can see doubt option is there right over here. Just click on this. And even right now during your live class, you can ask doubts. That's the best part about the YouTube classes on Vedantu J English. Imagine a YouTube class and Ved AI is helping you with your doubt in this particular section. And if you click on the description, then you will see that smart features like the smart notes, the PDF, everything will get uploaded after the session is over. So by tomorrow everything will be visible. So use this feature, guys. It's very, very friendly. Yeah, it's there in the description box. Ask with any doubts right over here. It's free of cost. If you have not yet logged in and created your Vedantu account, please do it. Yes, the subscription is free. Yeah, so it's much better than ChatGPT or Gemini because this is completely focused on academic content and relevant to your class and relevant to you and your studies. Okay, so it understands you. Right. Hello, Srikant, Arivaru, Ibu, Rehan, Sudarshan. Welcome, welcome. Abhinav, welcome. Sasi, welcome. User growth. Hello, hello. Good evening. Good evening. Hi, Anjali. Hi, everyone. Good afternoon. Good afternoon. Yeah, nice to see all of you. And the fire emoji spreading in the chat box. Hi, Dare to Shine. Hi, Harshima. Wow, Shreyas K, 86. Good evening. Duration will be 6 to 8 hours, man. Duration will be easily 6 to 8 hours. I'm not really sure, it can go a little longer or it might depend on how we conduct the class, but minimum 6 hours. Okay. So let's start with photons and photoelectric effect questions. Ready for it? Yeah, mainly we are going to focus on questions, but concepts also, if required, wherever necessary, I will help you out with it. So don't worry. And yes, Ved is always there. So you can use the Ved link and ask doubts. All right, cool. So, no, not 5 hours, man. Minimum 6 hours. 5 hours is too less. Which of the following theory is applicable for photons? Okay, read the question. Which of the following theory or concept or property is applicable for photons? Momentum is m into v. Kinetic energy is half mv square. The number of photons are always conserved in any process. They have no mass, yet they can apply impulsive force when they interact with the matter. What do you think is the right answer? Now, one thing about photons, their rest mass is zero, and when they are moving, their masses are meaningless because they move at the speed of light. So this velocity is actually the speed of light. Secondary thing, this mass will be zero, and when it moves at speed of light, it becomes infinitely large. So you cannot really define the mass of a photon. Okay, so this equation is only valid for electrons, protons, atoms, molecules, basically matter, not for photons, which is a particle of light. So photon not being a particle of matter, rather being a particle of light, these two equations are invalid. You can't even use half mv square. The energy of a photon is given by h into f, where f is the frequency of the light and not half mv square, because mass is not defined, even though speed can be speed of light. The number of photons is not really conserved because during transition of electrons within the atom, when a photon gets absorbed, the electron jumps to a higher orbit, and when the electron de-excites and comes to the ground state, a photon gets emitted. So photon can be emitted, can be absorbed, so the total photons may not be conserved. So it is conserved, it is given, which is also wrong. They have no mass, yes, mass is zero, and they can apply radiation pressure, radiation force, because momentum is still there with a photon. So momentum is not mv for a photon, it is h by lambda, where lambda is the wavelength of that light. So you cannot use these regular formulas for photon. You have to use energy is hf and momentum is h by lambda, then it works. These formulas are only valid for matter waves, or sorry, matter. So hence the option is D, and I can see many of you have marked the answer as a D. Very good, Praveen, Rohit, amazing, Harivasu, Harini, excellent. Rest mass is zero, correct. That is only rest mass, but remember, you cannot really find the photon at rest, because that means you're traveling at the speed of light, because a photon is always traveling, it is never at rest. So that rest photon is a hypothetical concept. So that is why you should understand the real mass of photon is unknown, undefined, and not relevant also. Yeah. All right. Yeah. Next question coming up on your screen, and here it is. So we are covering all the concepts of photons and photoelectric effects. So you might see some easy questions, some difficult questions, some medium questions, because certain topics there are no difficult questions, certain topics there are difficult questions, because it depends on the topic that we are doing. A laser produces a beam of light, output power of this much. The average number of photons emitted by the laser per second is how much? How many photons are emitted if the power is given? Now, power is nothing but how much energy comes out per unit time. This is the total energy. Now, this total energy is the number of photons multiplied by energy of each photon, multiplied by energy of each photon, and this divided by time. So, this will become n by t multiplied by energy of a photon is nothing but h into f. So I want how many photons are emitted per unit time. Therefore, n divided by t, n divided by t will be the power divided by hf will come below the power. So divided by h into f. So the power is 33 milliwatt. So 33 into 10 to the power negative 3, because milli is minus 3, divided by Planck's constant, which is 6.6 into 10 to the power minus 34, multiplied by the frequency, which is 5 into 10 to the power, how much is it? 14. Yeah. So you can see couple of things can be written down in a slightly better way, like this 33 and 66. So I can write this as 33 divided by 66 and multiplied by 5. So when I shift the decimal right forward, I have to increase the power. So 10 to the power minus 3 is still there, and below 10 to the power it will become minus 35, and this will become 10 to the power 14. So now we all know that 33 goes with 66 two times, and 2 5s are 10 basically. So it will be a power of 10. Essentially, no other thing will be there. So it should be option B only, because no other numeric value is there. Did you understand how I tricked it? without actually calculating all these things. I can see 2 5s are 10. Everything is a power of 10. In the options, there is only one option which has only powers of 10, and rest all has numbers like 2, 3, 4. But these numbers can never come with such a calculation. So it has to be 10 multiplied by 10 to the power 16, basically, number of photons per second. Hence option B. Very good. Excellent, Anjali, Ibu, Dhanu, Harini, Dare to Shine. Very good, Arivasu. Excellent, excellent, user Gautam. Yoke. Yep, correcto, correcto. Shall we go ahead to the next question? Everybody got it? Very good. All right. Here comes the next one. There are two sources of light. One is emitting 200 watts, and the number of, no, I think both the sources have the same power. The ratio of the number of photons of the visible light emitted by each source having wavelength 300 nanometers and 500 nanometers will be how much? Okay, their power is the same, but the colors which are coming out of it are different. Understand the question. Their powers are the same, the sources, but the number of photons will be different because the colors which are coming out are different. Now, if you use the same logic which you have used in the previous problem, model is very similar. This formula you use, N by T is P by HF. Number of photons per unit time is basically power divided by HF. You can see we can write frequency as, remember, our C is nothing but F multiplied by lambda. Therefore, 1 by F, if F comes below, will be lambda divided by C. 1 by F is lambda by C. So, I can just put lambda on the top and C over here. So, from this, it is very evident that N by T is directly proportional to the wavelength because power is same, H is same, and C is also the same. Yeah, same power. H is a constant universal, C is the constant speed of light. So number of photons which are emitted is directly proportional to the wavelength. So N by T for the first wavelength by N by T for the second wavelength will be just lambda 1 by lambda 2, which means it should be 300 by 500. Both are in nanometers, so no need to convert it. So hence it will be 3 by 5. 3 by 5, which is B option. How many of you gave B option? Yes, B for IIT Bombay. Perfecto. Amazing, guys. Amazing. Amazing. Proud of all of you. Great. Let's go to the next question on your screen, and here it is. The radiation pressure exerted by 450 watt light source on a reflecting surface 2 meters away from it is how much? Radiation pressure. Now we all know radiation pressure is nothing but 2 times intensity divided by C. This 2 has come because it is reflecting. That is why you are using this number 2. If it was an absorbing surface, then it is just I by C. So reflection gives double force or double pressure, whereas absorption is just singular I by C pressure, and force will be just multiplied with the area. Okay, now this formula you should know, and this comes from the momentum formula of photon. Momentum is h by lambda. Then from momentum you calculate energy. From energy you relate it to the force. So all of these things are there because every particle, when it strikes photon, it will apply some force, and the total force by total area gives me the pressure which is acting on that surface. That's the method to get it. But I do not know the intensity, so we need to get that intensity first. Now, intensity has a formula given by power divided by 4 pi into whatever distance you are from the source. Intensity is inversely proportional to the square of the distance for a point source. So the energy gets distributed on a sphere of area 4 pi r square. So that power divided by the area, which is 4 pi r square, gives me how intense the light is. That means energy per unit time, per unit area on that imaginary spherical surface. So use this over here. You will get P divided by 4 pi r square, and rest of the things as it is, 2 divided by C. 2 and 2 will cancel, and that What is it? We are been asked pressure. Don't get confused between this P and this P, or else you will cancel both of them. So I'll just put radiation pressure over here. So this is nothing but radiation pressure. So 2 and 2 will cancel. This is power divided by 2 pi C multiplied by R square. Now you just have to substitute literally everything. The power is 450 in SI units. 2 is 2 only. This you can put it as 3.14. Speed of light is 3 into 10 to the power 8. And the distance, it is at a distance of 2 meters away. So this will be just nothing but 2 square. So you just have to do this math now. 2 square is 4, 4 2s are 8. This is 3 into 3, which is approximately 9, you can say. All right, 9 and 45 goes 5 times. Yeah, this 3 and 3 is approximately 9. 9, it will be almost like 10 only, but close to 9. So 9 and 45 cancels with each other. Approximately, you can say the number is 5 on the top, and 2 square is 4, into 2 is 8. So it will be nothing but 5 by 8 approximately numerical value. Now 5 by 8, guys, is roughly how much? 5 by 8 roughly is how approximately how much, guys? Yeah, almost like 0.6, close enough to like 0.6. So there will be 6 in the numerical value. So without really actually calculating, I can tell that most likely the answer will be D. I don't have to sit and calculate what I have done. See, this is the trick, guys. I have 45 over here, and 3.14 into 3 is 9. 2 square into 2 is basically 8. 9 goes with 45 5 times. 5 by 8, this is 0.6. So, I can say it should have the number numeric 6 in the answer. So, directly mark D. Yes, there you go. How many of you understood? Yeah, exact value not needed. Yes, it is 0.625, but I don't need that exact value, because even here I have taken one approximation. I have not taken 3.14, I have taken it as 3. So some small approximation is done here. So that's okay. It will not be exactly 0.625. It will be something close to 0.6. So that is the trick which can save your time in calculations. Remember, calculator is not allowed. NTA mocked us, right? Just like we give mock test, they mocked us. We are giving you calculator. Then they said, no, 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 sorry, we're typing mistake. An intern was making the notice. So, calculator is not allowed. You calculate. But questions will still be of the same level. We think that calculator should be uh, there, and then we frame the questions. But it was a printing mistake. Questions will be difficult. So, NT, all the best. Okay, next question on your screen, and here it is. If a light beam of red and violet with same intensity are falling on an area, the number of photons which are striking per unit time is higher for red, higher for violet, same for both, can't say. Think about it. Yeah. All right. Come on, come on, come on, come on, come on. Everyone, everyone. Yes. Tell me, guys, what should be the correct answer for this? Yeah, playing with your life, correcto. Yeah. Hint is intensity does really depend on the frequency. If you think about the formula, you will get the answer. Some of you are confused between A and B. It is definitely not D. It is definitely not C also. I'll tell you why. Intensity Intensity is total energy per unit time, which is N by T into HF. This is the formula. Is that right? Okay. So indirectly, we can see for same intensity, our N by T, which is going to be I divided by HF, it is inversely proportional to frequency. Now we know for red, wavelength is larger, so frequency is less. So the number of photons per unit time will be more, because F is in the denominator. Whereas for violet, the frequency is higher, so the number of photons per unit time will be less. So the number of photons striking per unit time is higher for red and lesser for violet. So higher for red means option A is the right answer. Very good. It's not B. understood the logic of this? It's very natural to be confused between A and B, but hope the doubt is now cleared and the mistake has been rectified. You do n number of mistakes here, it is okay, but do not do anything wrong in the examination. Okay, that is the whole purpose of practice, mock tests, and revision. Got it? Very nice. This is a very good concept, by the way, because many people think it should be the same because intensity is same. Remember, whenever intensity is same for the same color, then n by t is same. Same color means same frequency, so n by t will be same. But if it is of different color, the number of photons will be different. Keep that in mind. So this is a common mistake with many students. The threshold frequency, we are slowly moving on to photoelectric effect. The threshold frequency of a metal whose work function is 6.63 electron volt is how much? Threshold frequency. Now that is that frequency for which what happens? You will see photoelectric effect will start occurring, below which it will not occur. So the work function is given by h into threshold frequency. H is nothing but 6.6 into 10 to the power minus 34. The work function is given in electron volt. So this will be 6.63 into electron volt means 1.6 into 10 to the power minus 19. So this particular part was that E. Okay, so I need to substitute that value of E to convert it into joules multiplied by the frequency F naught. I think we can cancel off couple of things over here, like this 6.6 and 6.63 will cancel. So I can clearly see my F naught value having the number 1.6. In fact, all the options now have 1.6 or 116. Okay, so I have no other option but to actually solve this. So 1.6 into 10 to the power minus 19 and minus 34 will go below. So it will go on the other side as plus 34. So 10 to the power plus 34 when you take it on the other side. So how much is the numerical value of the frequency? Come on, answer it in the chat box. C option, everybody is saying. Okay, 1.6 and how much this is? 10 to the power minus 19 and plus 34. That is basically plus 15. Obviously, this is in hertz. So 10 to the power 15, 1.6. Yes, option C is the correct answer. C for your Captain Shreyas. Excellent, guys. Harni, very good. Harshima, Sonu, Arivasu, perfect, perfect. Students 5324, very good. Dare to shine. Harshadullah, yes. Vishwanath, Shreya, very good, very good. Ibu, yes. C for Capto. Amazing, amazing. Let's move to the next one on your screen, and here it comes. There is light of wavelength 4000 Angstrom, which is falling on a surface whose threshold wavelength is 5420. Work function of that particular element is basically how much they have asked. Okay, how much is that work function? See, first of all, this wavelength is smaller. If wavelength is smaller, that means energy is higher, so photoelectric effect will occur 100%. So threshold wavelength is given. From that you can find the work function using this formula. Work function is hc divided by lambda naught. But if wavelength is given in Angstrom, then you have a convenient solution. You can write this as 12400 and divide the wavelength, but provided the wavelength has to be in Angstroms, then the final answer will be in electron volt. This is for simplification of calculation. So then what happens is you will get the work function as 12400. If it is nanometers, then it is 1240 divided by the wavelength, which is 5420. Whatever the answer is, it will be in electron volt because I know this is in Angstrom. Best part, we can cancel out 10 over here. Now, how to do this division? Are you going to sit and by heart the tables or write the tables of 542? No. Think logically. This is 1240. This is 542. So 1200 approximately. This is 540 approximately. So think like this. 542 times will be 1080. This is very logical. 543 times will exceed 1240. So the answer of this the answer of this must be less than 3, but it should be more than 2 because tables wise 540 into 2 is 1080. So 1240 is more than 2, but it is definitely lesser than 3. It is very obvious, else 540 into 3 will exceed 1500. So it should be somewhere between 2 and 3. There is only one option which is between 2 and 3. So I don't have to use my head and it will be just 2.29 electron volt. Directly I'll mark B option. Yes, it is correct. Understood, guys? These are some calculation tricks. It's not about, sir, should I do Vedic math, sir? Sir, should I do Abacus curve, sir? Sir, should I do some nice trick when teacher told me 4 lines, you should draw here, 3 lines horizontally, 1 line diagonally, then I count that lines. Not needed, bro. It's very simple. Use your common sense. Actually, this is more of common sense than teaching anything. Yeah? B for ID Bombay. Perfect. Understood these tricks. Shall we go ahead to the next question on your screen? Yeah, great. Let's go. See, the calculation was done. Why do you need to do all this nonsense? Not needed only. Okay. If an electron is in the excited state, falls to the ground state, excited to ground state, a photon of energy, 5 electron volt is emitted. Then the wavelength of the photon is approximately how much? If an electron, it's in the excited state, falls to the ground state, a photon is energy, or this much energy is emitted. What is the wavelength? Guys, just energy of the photon is simply hc by lambda. That's all. So if I want lambda, it is nothing but hc by energy of that photon. But this value of hc is 1240. Okay. And energy is nothing but how much? 5. So whatever answer you get in such a situation will be in nanometers. So remember this value of hc, h into c. Same trick which we have used in the previous problem. hc is 12400 if it is in Armstrong wavelength. If it is in nanometer, then 10 will vanish. That's the only difference. Okay. So it's just a matter of that 0 for nanometers versus Armstrong. Other than that, this number hc multiplication is 1240 if your answer of energy is in electron volt and wavelength is in nanometer. So guys, just do 1240 divided by 5. Yeah, how much will it be approximately? Think again, do your simplifications. Yeah, divided by 5, how much will it be? How much will it be? Close to, guys, 124 is close to 125. 125 divided by 5 is 25. So it should be 250. But it will be slightly less than 250 because this is 124 instead of 125. So the answer should be less than 250. So I can say it should be 248 nanometers without actually sitting and calculating it. Yes, it is option D. Very nice. Very good, Shreya. Yes, Arni. Yes, Anjali. D for IT Delhi. Yes, Kalyani. D for IT Delhi. Perfect, Shrikant, Siju. Aribasu, Shrikant. Amazing, Ramya. Amazing, amazing, amazing. Arshri, very good. Dare to shine. Excellent, excellent, Ritesh. Keep answering, guys, like this only. Very nice, very nice. Let's go to the next question on your screen, and here it is. A camera is fabricated to use semiconductor material, okay, having a band gap of 3 electron volt. The wavelength of the light it can detect is. See how they frame the same formula in different ways. Formula wise, it is the same, but the previous 3 questions, same formula, but used in different context. Once during work function, once during something else, electron transition, and once in band gap. So basically, you have a gap of energy of 3 electron volt. Only if the energy is more than 3 electron volt will you be able to detect that light or whatever. So essentially, that energy gap is nothing but the energy of that photon which will be detected, and the energy of the photon is hc by lambda, which you can also write it as 1240 divided by lambda. Provided this lambda is in nanometers, this answer will be in electron volt. So that's it. So energy gap is 3 electron volt. So this will be 1240 divided by wavelength. So therefore lambda will be 1240 divided by 3. Come on, guys, approximately how much will it be? Yeah, it will be close to 410 nanometers. 410 nanometers, but the closest answer over here is 413. So I think it should be C option. Yes, C option is the right answer. Closest answer is nearly. See, they have used the word nearly. So yes, we have got the approximate answer, more than enough. Yeah, C for Captain Shreyas. Perfect. Excellent. Let's go to another question coming up on your screen, and here it is. What does it say? Conductivity of a photodiode starts changing only if the wavelength of the light is less than 660 nanometers. The band gap of the photodiode is found to be x by 8 electron volt. The value of x is. Yeah, you can say it is a question from semiconductors, but you don't even need to know semiconductors for solving this question. It's actually a question on photons. Same kind of logic, band gap and wavelength. Band gap energy is energy of the photon. So whatever is that energy gap is nothing but the energy of the photon, and therefore it will be again 1240 divided by wavelength, provided the wavelength is in nanometers. The answer over here will be in electron volt. Do the same thing. That band gap is x by 8 electron volts, so it will be x by 8 in electron volts. 1240 divided by wavelength. How much is the wavelength? 660. From this, you will get the value of x. 0 will cancel. 124 multiplied by 8 divided by 66. Come on, my dear students. How much are you getting the answer as? Yeah, approximately how much are you getting the answer? Yeah, let me know, guys, quickly in the chat box. Yep, come on, do the math. 8 goes with 2 4 times. This goes with 2 33 times. This will multiply and go how many times? Guys, come on, almost really close to 4, but not 4. So 4 4s are 16. So answer should be less than 16. So I think it should be 15 approximately. Yeah, just check it out. Approximately 15 should be the answer. Let's check out. Yes, answer is C. Perfect. Very good. Amazing, amazing, amazing. So these kind of questions do come again and again. And I just wanted you to see that same formula is coming, but in different context. Sometimes in semiconductor, sometimes in atoms, sometimes in photoelectric effect. Okay. Similarly over here, work function is given, the wavelength which will cause the photoelectrons emission. Same concept. I would say take this as homework. Okay, take this as homework. We need not have to do it over here. Very similar formula. Use 1240 by lambda is equal to the energy. You will get the answer. We will not do it over here. Okay, let's take another type of question now. So work function is given. Which color will give rise to the photoelectric effect? Now, for the photoelectric effect to happen, frequency should be more than the threshold, or the wavelength should be lesser than the threshold. So frequency is proportional to energy. So frequency increases, energy increases. Same way, wavelength decreases, energy increases, because lambda is inversely related to the energy. So you just need to think what might be the threshold wavelength if this is the work function. So work function is hc divided by lambda naught, which is again 1240 divided by lambda naught, provided again this is in nanometers and this is in electron volt. So from this we will get lambda as 1240, lambda naught as 1240. Take work function below, which is basically 3. So that will give me close to 400 and 410 nanometers approximately, close enough to that. 410 nanometers. Now, when will photoelectric effect occur? When will photoelectric effect occur? Think about it. When lambda is less than lambda naught, then that photoelectric effect is going to occur. So that means my wavelength should be less than 410 nanometers. Now 410 nanometers is close to the blue range, blue violetish range, blue violet, that range you are in, because visible spectrum is close enough to 400 nanometers for violet spectrum, to red is at 700 nanometers. So red, green and yellow can't be there. It has to be blue color, which is C option. Again, C for Captain Shreyas. Looks like the options need to be shuffled, guys. Every time we are getting C option. Oh, no issues. Yeah. The session will be for easily 5-6 hours. Yeah, man. Okay, cool. And you guys also will need some break in between because we can't just solve continuously problems. We also will need some break. So we'll take those sufficient breaks. So 6 hours bare minimum, you can think. Work function of cesium and lithium are 1.9 and 2.5. If 550 nanometers is incident, then photoelectric effect is possible for which situation? Okay, think like this. Which of these elements will give photoelectric effect? I have an idea. Rather than figuring out what are their threshold wavelengths, figure out how much energy of light is 550. So the energy of that light photon is nothing but 1240 divided by whatever that 550 was there. I'm going to put it over here. 0 cancels. 124 divided by 55 is roughly how many electron volts? Come on, guys, answer it in the chat box. 124, you just divide it by the number 55. Roughly how much will it be? It will be 2 point something, but 2 point how much? Will it be more than 2.5? I don't think so. I think it will be close to 2.2. Just check it out. It will be around 2.2 electron volt. Now, this is the fun. See, 2.2 is more than 1.9. So for cesium, photoelectric effect will occur. But that same 2.2 number, energy-wise, is lesser than 2.5. Is lesser than 2.5. So for lithium, that photoelectric effect will not occur. So hence, only for cesium. So that means D option is the right answer. No, it is not C. It is a D. Be careful, not lithium. Guys, I think you got exactly opposite answer. Don't get confused. Yeah. So find the energy first. If the energy of the photon is higher than the work function, then it will occur, not occur. Okay. Energy of the photon is bigger than the work function. That means it has enough energy to suck out that electron. Then photoelectric emission will occur. But in case of lithium, photon has lesser energy than the minimum energy required. So there is no photoelectric effect. Hence, only cesium. Be very careful. These are, yes, silly mistakes. These are silly mistakes. You think about something, you know it, you can do it, but still you make that mistake. That is a silly mistake. It's not that you're not studied it. Yeah? Where? Yes, very true, Kalyani. Incident energy should be more than that. Next question on your screen, and here it is. In a photoelectric experiment, light of frequency 1.5 times the threshold frequency is made to fall on a surface whose is photosensitive. Now, if the frequency is half and the intensity is doubled, how many photoelectrons, the number of photoelectrons which will come out will be doubled, half, zero, quadrupled. Now, there is a direct relationship between intensity and number of photoelectrons which are emitted. Intensity is directly proportional to the current, and the current is directly proportional to the number of photons which are emitted per unit time. It is clearly mentioned intensity is doubled. So if intensity is doubled, current should have been doubled and the number of photons should also be doubled. Hence, you will mark option A. But there is a catch. What is the catch? Observe clearly. Light of frequency 1.5 times the threshold is incident. So initially, the frequency of the light was 1.5 times of the threshold frequency. Final light has a new frequency which is half of the previous one, which is f by 2, which means it is 1.5 f naught divided by 2, which is 0.75 f naught. Now this is the catch. This is less than the threshold. 0.75 is a number less than 1. So it is less than the threshold, which means photoelectric, photoelectric effect will not occur. So even if you think intensity should double the current and the number of photons, this doubling only will not happen because of this. So the actual current will be zero. Number of photons coming out of it will be also zero. Hence the answer is C. So this is a very nice trick question. Many kids are going to fail this and get negative marks even after knowing it. So you will most likely ignore this part. There is a good chance you will just think intensity doubles, current doubles, number doubles. That is wrong. Okay? Is that clear? Yeah. These questions are based on the PYK models. Yes, definitely. Moving on to the next one on your screen, and here it is. There is a photon of 5 electron volt which is falling on a surface whose work function is 2 electron volt. What is the stopping potential? Interesting, simple, direct question. Use Einstein's photoelectric equation, which says energy of a photon is the work function plus the maximum kinetic energy, which can be written down as E multiplied by Vs. Energy of the photon is 5 electron volt. Work function is 2 electron volt. This is E multiplied by Vs. As one can see, this E, this E and this E just got cancelled off. So therefore, my Vs should be the number 5. Take that 2 on the other side. So minus 2. So that should be 3. But this will be also in volts. So 3 volts. Oh, sorry. This electron volt should not have been there. There is a printing mistake. The stopping potential is always going to be in volts, guys, not in electron volt. Yeah. So the answer should be 3 volts. Yes, the answer is 3 volts, not 3 electron volt. I'm just changing that over here. Okay. Perfecto. There you go. Clear, guys? Understood? Very direct, simple question. Yeah. Again, C for Captain Shreyas. Moving on to the next one. Coming up on your screen. Coming up on your screen. Come on, guys. A photon is incident on a metal whose work function is given, and a photoelectron has energy 2 electron volt is emitted. The wavelength of the photon is roughly how much? Wavelength of the photon falling to emit that electron is asked. Again, have to use the photoelectric equation given by Einstein. So, we can say energy of that photon is the work function plus the maximum kinetic energy, which is also EVS. So this will be nothing but hc divided by lambda is equal to work function. Work function is how much? 2 electron volt. 2 electron volt plus maximum kinetic energy is also 2 electron volt. So this will become 4 electron volt, right? But I already mentioned that instead of hc, you can also use the number 12400 electron over here, and lambda will be then in your Armstrongs. Lambda will be then in your Armstrongs. So this small thing you can do. So you can see electron and electron will get cancelled, and you can just rearrange this equation. So lambda in Armstrongs will be 12400 divided by the number 4. So how much will lambda be approximately? Yeah, it's no brainer. It will be 124 by 4 is 31. So 2 zeros over here. But obviously this should be in Armstrongs because I just told you this is in Armstrong. So this will be also in Armstrong. So 3100, which is B for IIT Bombay. Yeah, got it, guys? So this number is very important. For Armstrong, 2 zeros are there. For nanometers, 1 zero is there. But that number 124 is very, very important. So it comes again and again and again. Yeah. Very good, guys. Very good. Keep it up. Keep solving like this only. Very good. Mohana, Harshni, Harivasu, Shreya. Very good, Vishwana. Lovely, lovely, Ritish. Lovely. Amazing, amazing. Very good. Keep it up. Very good, Savita. Very good, Harshima. Yes, Mona. Correct. Let's go. Let's go to the next question on your screen. And here it comes. See, guys, if you do not know that number, then it becomes little bit lengthy if you do not know these value. Okay, 1240. It will become lengthy because H value you have to put, C value you have to put, you have to convert it into electron volt. Unnecessary calculations will be there. Photoelectric experiment where energy of 2.48 electron volt irradiates a photosensitive material. That means, see, they have made a complex statement, but it is very laddu. This is the energy of the light. The stopping voltage is given. What is the work function they have asked? Guys, I think we will be able to do this. Not a difficult one. Again, use Einstein's equation. Energy of the photon is work function plus the E into Vs by, because stopping voltage is given. So energy of the photon is given to be 2.48 electron volt. Work function is asked plus E into stopping voltage is how much? 0.5x. So therefore, work function is 2.48 minus 0.5, the whole thing into E, which is 1.98 electron volt. So the work function is 1.98, which is A option. How many of you got A option? Yes, finally A. Yes, correct. Very good, Abhinav. Yes, Satvik, Shreya. Very good, Ibu. Yes, Ritish. Very good, Harni. Yes, Dhanush. Arivasu, Harshini. Correct, 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 correct. Very good, very good, very good. Moving on to the next question. And as you're loving this session, smash that like button. And if you have not yet subscribed, subscribe to the Vedantu J English channel. Okay, very, very important. A lot of marathons are coming for your winter vacation or your Christmas vacation, or because your pre-boards are almost done or maybe done. So make sure you're attending every single marathon being conducted over here, either at 3 o'clock or at 11 o'clock. Okay, so we'll try to keep it at 3, but some days might be at 11 o'clock. Lights of two different frequencies whose photons have energy, this and this, illuminate a metal whose work function is 0.5. Ratio of the maximum speeds is how much? Interesting. Again, if you use photoelectric equation, energy of the photon is work function plus maximum kinetic energy, which means it is half m v max square. This is what it is. So for the first light, the photon has an energy of 1.5 electron volt. The work function is the same for both of them, plus half m v max square. So therefore, half m v max square will be 1.5 minus 0.5 times of E, which is basically 1 times of E. This is the first scenario. For the second scenario, the light has an energy of 2.5. So 2.5 electron volt. Work function is going to be still the same, plus half m V max square. So therefore, half m V max square will be 2.5 minus 0.5 whole thing into E, which is nothing but 2 times of E. Now the question says, what is the ratio of their speeds? So if you take V max in the first case, V max in the second case, if you divide both these numbers, half m cancels, I'll be getting the ratio of their squares. It will be nothing but 1 divided by 2. So therefore, taking square roots, V max in the first case upon V max in the second case will be 1 by root 2. That should be the answer. 1 by root 2 means IIT Delhi. That is absolutely correct. Yep. This is D. Yes, correct. Ritish, Harivasu, Savita, Harshni, yes, Abhinav, yes, Kalyani, perfect, yes. Ritish, Suju, correct, 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 correct. Very good, Vimla. Amazing, amazing, amazing. Moving on to the next question on your screen. Okay. When a metal is illuminated by light of wavelength lambda, stopping voltage is 8 volts. Okay. New light, new voltage will be there. So when light is changed to 3 lambda, the voltage changes, stopping voltage changes to 2 volt. What is the threshold wavelength? So a little bit of manipulations will be there. So in general, what will our equations look like? Think. First time, when light of wavelength lambda is falling, the energy of the photon will be EP, work function will be phi, and stopping voltage is there, so E into Vs. So for the first situation, Hc by lambda, work function I do not know, but I think we have to find out the threshold wavelength. So this I can put it as Hc by lambda naught plus E into V is there. In the second scenario, my wavelength has been changed to 3 lambda instead of lambda, 3 lambda. Work function obviously won't change, plus stopping voltage has now become 2 times of V. Hold on. This voltage, and I have to do everything differently only. So this was lambda naught. Stopping voltage was 8 volts. Okay, the stopping voltage was 8 volts, not V volts. It was 8 volts. So I just changed it. Second time it is 2 volts. Now, in order to get rid of the voltage, I will now actually multiply the second equation 4 times. Then it will make sense. So this will become 4 Hc by 3 lambda is 4 Hc by lambda naught plus 2 4s are 8, 8 times of E. Why did I do it? Because when I subtract them, when I subtract these two, this with this, 8 EV and 8 EV will just get cancelled off. So what do I do now? I will write this as 4 Hc divided by 3 lambda minus Hc by lambda is equal to 4 Hc by lambda naught minus Hc divided by lambda naught. Now 4 by 3 minus 1 is basically 1 by 3. So this will become Hc by 3 lambda is equal to 4 minus 1 is 3. So this will become 3 Hc by lambda naught. Hc will cancel. So 1 by 3 lambda is 3 by lambda naught. So therefore, lambda naught will be 3 multiplied by 3 lambda, which is 9 times of lambda. So 9 lambda is there as option B, and that is absolutely correct. Yeah. Yes, Harni, I corrected it. Yes, Ibu, I corrected 8V. 8 volt. Yes, 8 volt in the first case. I just changed it, or else we would not have got the answer. All right. Cool. Shall we go ahead to the next one? Coming up on your screen. Here it comes. A very similar question has come multiple times. You will see most of the JEE Mains papers has this model of question. Wavelength is lambda, voltage is V naught. Wavelength is 2 lambda, voltage is V naught by 4. What is the threshold wavelength? Again, similar model. Now tell me, will you be able to do this kind of question? Yeah, I'll just help you with the equations. All right, rest things you can do it as 4. H C by lambda in the first situation is Hc by lambda naught and stopping voltage is V naught. In the second situation, it is Hc by 2 lambda is equal to Hc by lambda naught and stopping voltage becomes E V naught by 4. What will you do to solve this? Yeah, you are going to get rid of EV naught. How? Multiply this equation with 4 times. So things will be very easy. So 4 Hc by 2 lambda is 4 Hc by lambda naught plus just E into V naught when you multiply it 4 times. So also this 2 cancels with this 4, it will become 2, and then subtract these 2 to get your final answer. Come on, do it quickly and tell me what is it that you are getting. Just subtract these two and you will get the answer, guys. So 2 Hc by lambda minus Hc by lambda will be 4 Hc by lambda naught minus Hc by lambda naught. EV naught goes off. Solving two equations simultaneously, it's exactly that. So this is Hc by lambda is 4 minus 1 is 3 Hc by lambda naught. So 1 by lambda is 3 by lambda naught. So lambda naught is 3 lambda. So it should be option A, I believe. Yes, it should be option A. Perfect, perfect, perfect. So this model is very, very common. Awesome, awesome, awesome. Let's go to another model of question coming up on your screen. In a photoelectric setup, an electromagnetic wave means light or a photon falls and electrons are ejected. When the work function is given to be 2.14 electron volt and stopping voltage is 2 volts, what is the wavelength of that light? Stopping voltage is given, work function is given. Guys, use your Einstein's equation. Energy of the photon is the work function plus E into Vs. Work function is 2.14 electron volt and stopping voltage is 2 volts, so 2 into E. That is energy of the photon, which is 1242, and this is divided by wavelength. Remember, this wavelength will be in nanometers and this 1242 will give me the answer in electron volts, so E will be there. So what also happens is this E and this E will cancel. So that is the trick. HC is 1242 instead of 1240. They have given it as 1242. Just a small change. It is okay. And now you can solve this question. So this will just become 2 plus 2, 2.14 is 4.14 and this is 1242 divided by wavelength. So wavelength will be 1242 divided by 4.14. How much will it be approximately? Yeah, come on guys, this will be close to 300 nanometers. Just check this out. Answer should be C for Captain Shreyas. Yes, it is. Yep, perfect. So most of the times this kind of questions do come in the examination. I'm glad that you are slowly gaining that confidence. See, similar model, if you solve 4-5 times, what is happening? That is the whole purpose of this practice sessions. You are getting that confidence. Now, you're like, yes, sir, now I am Pakka, 100% it is fit inside my head. Now any question comes like this, I will be able to solve. So don't ever feel overconfident when you're solving. Now I can do it. Now I know. Oh, first two lines I see, I can solve the rest. This overconfidence is exactly what sucks away your marks in the mock test, because you feel you know it, but when you actually write it, solve it, in that stress, that's where you get stuck. So even if you feel you know it, solve it, practice it 2-3 times, similar models, similar questions. That's it. That will enter your head now. Next one. A light source of some wavelength illuminates a metallic surface and electrons are ejected with maximum kinetic energy of 2 electron volt. If the same surface is illuminated by a light source of wavelength lambda by 2, then the maximum energy is how much? Interesting. Wavelength changes, maximum energy will also change. Question is, what is that change going to be? Okay, so let's figure it out. Okay, work function is also given. Okay, so first of all, I can say one thing, that energy of our photon is the work function plus the maximum kinetic energy. Is that right? That is the basic equation which we'll start from. Okay, come on guys, focus on the class. Focus on the class. Now, what we are going to do is, the energy of the photon is not given, but wavelength is given. So wavelength is related to the energy by hc by lambda. Work function is 1 electron volt, so 1e plus maximum kinetic energy not given, so I'll just put Ke max. But in the first case, the kinetic energy was given, and that kinetic energy was given to be 2 electron volt. So 1 plus 2 is 3. So 3e is hc by lambda. This is the first thing which I got from the first given scenario. Now again, using the same Einstein's equation, next time the energy will be different because wavelength is different. So it will be hc divided by lambda by 2 is work function, which is still going to be 1e. What is the new maximum energy? The 2 goes on the top. I will get hc by lambda is 1e plus maximum kinetic energy. But I'll tell you one beautiful thing which happens. Can you see these numbers, hc by lambda? It's there here also. So that is technically nothing but 3 electron. So just put 2 multiplied by 3 electron. 2 multiplied by 3 electron is equal to 1e plus maximum kinetic energy. So my maximum kinetic energy will be 2 3s are 6, minus 1e, which is 5 electron volt, which is option A. So a very nice manipulation. From the first piece of information, we figured out hc by lambda. Don't be stupid to find the value of lambda, because that will unnecessarily delay your answer. Why do I need to find lambda when I can substitute hc by lambda itself in my second equation? So unnecessarily don't sit and calculate random things. Wherever required, avoid those calculations. Try to substitute a big thing into another thing which can be directly, related, and save lot of your time. Okay, so we didn't have to really find the value of lambda. That is the good thing. Okay, cool. Let's go to the next question on your screen, and here it is. Ultraviolet light of energy whose photon's energy is 4.13 electron volt falls on a metallic surface, which is photosensitized, has a work function. What's the maximum kinetic energy of the photoelectrons ejected? Okay, I think you should be spamming this particular answer. Yeah. Sir, I did 1 minus 2 equation and got the answer. That is also fine. Yeah. I'll be sharing the slides by tomorrow. You will get it. Ved AI link is there. So Ved will analyze my entire session. It will also generate smart notes, smart problems, quizzes on that. So it takes time. Ved has to watch all our videos. So it will take that time, and it will present to you the smart notes, everything along with the actual slides also. Okay, don't worry, by tomorrow. But that's not the point. The point is also to watch the class live, because otherwise you will be wasting your time just chumma whiling away. You think you will solve many questions, but no. Today I'm making you solve 123 questions with me of modern physics, and I did not take entire physics because I know then each topic will not get that justice. So when I take only a specific unit, now we will be solving almost all topics, almost all model questions. So there is nothing left only. It is a perfect revision for all of you. Okay. So energy of the light, which is energy of the photon, is work function plus maximum kinetic energy. Energy of the photon is 4.13 electron volt. Work function is 3.13 electron volt plus maximum kinetic energy. So maximum kinetic energy is 4.13 minus 3.13, whatever the answer is in electron volt. So this is 1 electron volt, which is B for IIT Bombay. Yeah, B for IIT Bombay. Recently, hostel number 19 was inaugurated in IIT Bombay. It's beautiful. Some of you might have seen it in the news. During my times, it used to be like hostel number 9, 10, 11, then 13 was just starting. So now it has gone to 19. So it also shows that the strength of the students has increased drastically from my time to your times, almost like double capacity nearly. And the rooms are also modern and everything. But yeah, I mean, it's also a privilege, and also very few students get that chance to actually stay in the hostel because you are studying over there. So I want all of you to focus your energy in that dream of yours to finally be in the IIT hostel. And if anybody else is telling you IIT is not needed, NIT is not needed, triple IT is okay, you can study in some random private college also, still you will do well. Don't listen to such people, because only teachers and people who have studied from the premier institutes can vouch and tell you it is very different from what you might get in a random private college. So guys, full focus, full energy on your IIT JEE preparation. Yeah? All right. I'm so glad, Ebu, for that super chat out there. Great. Yes. Let's move to the next one on your screen, and here it comes. Ultraviolet light, ultraviolet light of this much wavelength is falling on a work function. Then the stopping voltage is how much? All different variations in that same photoelectric equation again. So if I write hc by lambda, which is energy of the photon, is the work function plus E into Vs. This hc is 1240 electron volt divided by wavelength, always has to be nanometers, is work function, which is 2.13 electron volt plus E into Vs. First of all, let's get rid of this E from all the sides. This 0 will also cancel out. 124 and 3 divisible, yeah, nearly. So what will be the answer, guys? Close enough to 410. So this will be nothing but what? 4.1. 4.1 is equal to 2.13 plus stopping voltage. So stopping voltage will be almost, this is not exact, guys, this is approximate. So approximately how much will it be, guys? Approximately how much will it be? Yes. How much will it be? Very good. Almost close enough to 2 only. It's not exactly 2, but close enough to 2 volts. That should be the answer. Yeah, let's see. Yes, 2 volts. That is the correct answer. Very good. B for IIT Bombay again. Amazing, 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 amazing. Amazing, guys. Proud of all of you. Many of you answered it. So moving on now to the next question. Oh, now we have come to some graph-based questions. Lot of numericals done. Now we are going to come to the graph-based questions also. Get ready for it. If you take photoelectric effect, the maximum energy of the photoelectrons is plotted against the frequency. The slope of this graph is exactly what? Come on, think. What does the slope of this graph really give you? Interesting. Energy versus frequency. What is the slope going to give me? Maximum kinetic energy versus the frequency. So it's not like you will remember it, nor should you by heart it, but rather just derive it normally. Energy of the photon is the work function plus maximum kinetic energy of that electron. So this is our photoelectric equation. By the symbols which have been given over here, the maximum kinetic energy has a symbol of Ek, energy of kinetic. Energy of the photon I can write it as HF. So rearranging it, Ek will be HF minus phi. Now compare this with y is equal to mx plus c. You will quickly realize m is like h and c is like negative phi, and this is the equation of that straight line. So m is nothing but the slope of that graph. So the slope is nothing but the Planck's constant. Hence, the correct answer is option A. Okay, it's very simple. Don't try to remember. So where did I study it? Studied this. But if you just manipulate the equation, you will get the answer. So don't always have to think which formula I have to by heart, which formula I should recollect. This is not a formula. You have to understand the application of that formula and convert it into a graph and then compare it with straight lines. Yeah, Planck's constant. Option A for IIT Abu Dhabi. Wow, nice. We finally got IIT Abu Dhabi, and very soon, I'm pretty sure worldwide we are going to have IITs, and in India also we are going to have MITs and Stanfords and all the top-notch colleges around the world setting up their campuses. So you don't have to really waste so much of extra dollars to study abroad. Variation of stopping voltage as frequency is given. What's the work function? Now this is a standard graph and you would have studied it, but in case you have not studied it, no issues. I'll tell you what. See, stopping voltage and what is that? Frequency, right? So energy of the photon is the work function plus E into stopping voltage. Okay, this is the photoelectric equation. Rearrange this equation. So you'll get E V naught is HF minus phi. Divide this with E. So you will get H by E into F minus phi divided by E. Now compare it with Y is equal to M into X plus C. Your intercept on the y-axis is negative phi by E, and this M, which is your slope, is H by E. This Y is just like the stopping voltage, and your frequency is on the x-axis. This is exactly a straight line equation, just like the previous problem. The question is, what is the work function of it? Now, if I want to find the work function, I have to find the y-intercept and all of that. But I will say, don't even have to go that far. Think like this. When my frequency will reach the threshold f0, this stopping voltage will become 0 volts. Will become 0 volts. Is that right? Means wherever it intersects the horizontal axis. Why horizontal axis? Because y coordinate should be 0. My y coordinate is 0 exactly at this point, and this is my threshold frequency. So when your light has exactly that energy of the nearly that energy of the work function, then the electrons barely have any energy. So to stop them, you barely need any volts. So that is why this point becomes F0. That is the crux of this problem. Actually, then you don't have to do all these things. That is why I said, do you know this graph? If you know this graph, you will avoid all this, and you know this point has to be F0. And so directly you will say, the threshold frequency is 5 into 10 to the power 14 hertz. So my work function, which is HF0, will be 6.6 into 10 to the power minus 34 into threshold frequency, which is 5 into 10 to the power 14. So 6.6 into 5, that's not 3.3, it will be 33. Yeah, this will be 33, and this will be 10 to the power minus 20, but this answer will be in joules. I don't want to leave the answer in joules, so I will divide it with 1.6 into 10 to the power minus 19, so I get the answer in electron volt. And now the answer which will come out to be, yes, 16 and 32 goes 2 times, so this will be 20 times approximately, into this minus 20 and minus 19 will make it 10 to the power minus 1. So this will be 2 electron volt roughly. So that will give me answer as D, which is correct. Perfect. So calculation wise, need to be little careful over here, because answer is not in joules, it is in electron volt. Otherwise decimals are also important. Yeah. Perfect. Kudos to all of you who got the right answer. Next one on your screen, the stopping voltage versus frequency of a photoelectric effect in a metal is given. Similar graph, guys, voltage versus frequency. And if you notice, the previous question was also similar thing, voltage versus frequency. So these graphs are always straight line with this equation. So keep that in mind. So the question over here is, what is the value of the Planck's constant? It seems like a strange question initially. Sir, Planck's constant is 6.6 10 to the power minus 34. But almost all the options are very close. So you cannot by heart the value and put it. You have to put the value which you get from the graph, even if it is slightly different from the exact value of the Planck constant. So that is the catch in this kind of problem. And we know that for such graphs, this equation is valid, V naught h by E f minus phi by E. So we can write down V naught is basically h by E f minus phi by E. So this particular thing is nothing but the slope, and the slope of this graph, y by x-axis, yeah, you can take it right over here and you can get the answer. So what is the delta y for the slope? Slope delta y is nothing but 1.23 divided by the base, which is 8 minus 5, I believe. So this was 1.23. This much is between 5 and 8. It is nothing but 3 into 10 to the power 14. So this is 3 into 10 to the power 14. Yeah. So this is the slope, and that is numerically equal to h by E, and E value is 1.6 10 to the power minus 19. Now multiply and get the correct answer, which will be 1.23 into 1.6 into 10 to the power negative 19, whole thing divided by 3 into 10 to the power 14. Just see how much are you getting the answer as. Just check it out. How much are you getting the answer as approximately? Yeah. 1.23 into 1.6 divided by 3. Just do this math first and see what are you getting as the answer. 123 is divisible by 3, guys. Come on, do the math. Everyone, come on. How much will it be? 123 is divisible by 3 right over here, and tell me what are you going to get. This will be 41. So this will be 0.41. Yeah, that's right. And 0.41 multiplied by 1.6. Just see how much are you getting. And over here, this will become 10 to the power minus minus 33. And check this out. Are you getting this as 16 for the 64? So 0.66 approximately. So this should be 6.6 into 10 to the power minus 34. That is basically option A, I believe. Yes, that is the correct answer. Yeah, that is the correct answer. Just check it out. Option A. Perfect, 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 perfect. Yeah. Yeah, we should take delta 1. This is delta 1. 1.23 minus this point. So the change in the height is 1.23 upon delta x. That is what will give me the slope. Okay, so be very careful over here. In this particular triangle, this height upon the base will give me the answer. Okay, for the slope. So these kind of questions are also very common. Let's go. Next question. Again, graph based. Which of the diagram shows correct variation of voltage versus the current for two different intensities of light? This is a standard graph. This is a standard graph. Come on. Yes, exact value might be 6.56, but in the option 6.56 was not given. So we will mark it as 6.6. Okay. 6.56 rounded off to one decimal will become 6.6. Okay. What do you think is the correct answer? Irrespective of the intensity, stopping voltage is same. So there is only one graph like that, and intensity can never change the stopping voltage. If you increase the intensity, current also increases, and yes, it should start from the negative side, stopping voltage, and it should keep on going up and it saturates. So it is the third option, I believe. Number 3, yes, perfect. Standard graph, as you increase the intensity, current increases, and eventually the current saturates. It can't increase beyond a certain limit. Keep that in mind. Okay, moving on to the next one. Statement based and graph based, both combined. Diagram is showing stopping voltage versus frequency for two materials. Slope gives me h by E. H is Planck's constant and E is the charge of the electron. Statement 2, M2 will emit photoelectrons of greater kinetic energy for the incident radiation having same frequency. Which of the following are correct? Interesting. Yes, interesting. Yes, Kalyani, absolutely right. Let's see whether you are able to figure this out. The very similar formula based question we did it. I just told you stopping voltage is nothing but H by E into our frequency minus work function by E. Now in this, I told you this particular part is nothing but M, which is nothing but the slope. So this is stopping voltage, which is there on the y-axis. This frequency is there on the x-axis, and this entire thing is the y-intercept. So if you compare that, the slope gives me the value of h by E, and E is the charge. So statement 1 is absolutely right. There is nothing wrong in it. Okay. Now what about statement 2? How do I do that? Say, one thing though over here, this is threshold frequency, this is also threshold frequency. This has smaller threshold, this has larger threshold. This is F0 for 1, this is F0 for 2. So F0 2 is more than F0 1. That means work function of 1 is less than work function of 2. That means if you make light fall, on these two materials, then the kinetic energy in the first case will be more as compared to kinetic energy in the second case, because less energy is required to suck that electron out of the metal. So kinetic energy will be higher because more energy is available for the electron, because very little energy is required to pluck it out of the atom. So K1 will be more than K2. So M2 will emit a greater kinetic energy. This is not greater, this will be lesser. So statement 2 will be incorrect. So option A is the right answer. 1 is correct, 2 is wrong. Did you understand the logic behind it? I'll again explain. Energy of the photon is the work function plus kinetic energy. So this was same. It was given that it is the same for same frequency. So same. So wherever this is more, this is less. So wherever that is more, that is less. Kinetic energy is less. That is the logic behind it. Got it, everyone? So a very nice statement based plus graph based question combined together. Next question, statement based. Which of the following statement is not true about stopping voltage? It depends on the frequency of the incident light. It is 1 by E times the maximum kinetic energy. It increases with the intensity of the light which is falling on it. It depends on the nature of the material. We all know energy of the photon is work function plus your E into Vs. Energy of the photon is H into F, work function, you can say whatever, phi plus E into Vs. Now, one thing, nature of the material decides phi. So if phi changes, Vs will change. Then it depends on the frequency of the light. You can see F is there over here. So if frequency changes, then stopping voltage will change. It's 1 by E times maximum kinetic energy, which is also true. This entire thing is actually the maximum kinetic energy. So Vs will be K max divided by E. So stopping voltage will be maximum kinetic energy divided by E. So even this is correct, this is correct, and this is correct. This is anyways wrong. You could have directly marked it because intensity has got nothing to do with stopping voltage. In fact, I showed you the graph here also that stopping voltage is independent of the intensity. They will always converge at the same point. So it should be definitely option C. Got it? Yeah. I have explained you other options. It's not just about marking the correct answer and moving ahead. You should also know why other options are correct and why this was wrong. Okay. Next one. Uh, Again, a statement based. In a photoelectric effect, stopping voltage. I think this one though we already did. Yes. The stopping voltage is 1 by E times of this. So Vs is maximum kinetic energy divided by E. So this is correct. Increases with the intensity of the light, definitely not related. Decreases with the intensity, wrong. Increases with the increase in the wavelength of the incident light. This is very critical. See guys, energy of the photon is hc by lambda, is work function plus E into Vs. So if wavelength increases, this whole ratio will reduce. So LHS will reduce. So the whole of RHS should reduce. So the stopping voltage will also reduce. So it increases with the increase of it. That is wrong. It should decrease. So it will not increase. It will decrease. That will be the correct one. So anyways, first option was correct. You don't have to look at other options. But I told you what is the exact variation for D. Cool. Very similar kind of question. Very good. Moving on to the next question coming up on your screen. Photoelectric effect stopping voltage versus frequency curve is plotted. Then the graph is linear. The slope is phi by h. H constant is related to the slope of the voltage versus frequency line. The value of electric charge on the electron is not required to determine the uh, value of H. the work function can be estimated without knowing the value of H. Okay, interesting. So again, that same graph where you can say this is stopping voltage, this is our frequency, and that graph, right? It goes like this, and it is like that over here. Okay, and this y-intercept is minus phi by e, and the slope is basically h by e, and this value is basically threshold frequency. This is how that graph is. Now let's see one by one which options will be correct or which options are wrong. This graph is a straight line, 100%. So A is correct. Slope is phi by h. Is the slope phi by h? No, it is h by e. So second part is, B part is obviously wrong. H is related to the slope. Yes, the slope is related to h, definitely. The value of the charge of the electron is not required to determine the h using that slope. Oh, what do you think? The value of the electric charge of the electron is not required to determine h using voltage versus the frequency curve. What do you think? You require it, right? It says it is not required. This is wrong. We definitely need it, because if I know the slope, I need E to find the value of H, okay, to determine the value of H. So D is wrong. The work function can be estimated without knowing the value of H. Yes, even without knowing the value of H, you can estimate the work function. You can see that. So definitely what is this? E option is correct. Then what else is there? Yeah, that's it. A, C, and E. A, C, and E. So it is option A. Yes, perfect. A, C, and E. B and D were wrong. Yes, option A. Yeah. Yes. Perfect. Guys, amazing, 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 amazing. Moving on to the next question. In a photoelectric effect, if the intensity of the light falling on the setup is made half, intensity is made half, stopping potential reduces, maximum energy of the electron reduces, photocurrent reduces, threshold wavelength increases. Direct, guys, theory based. Come on. Light's intensity has got nothing to do with the stopping voltage nor the kinetic energy, because voltage and kinetic energy are related. In fact, even the threshold wavelength just depends on the material. So it is the current which reduces, intensity reduces, current reduces. Intensity increases, directly it will increase. So it should be C option. Just check it out. Yeah, very good, very good, very good, very good. Amazing. Moving on to the assertion reason question. In a photoelectric effect, when you increase the intensity of the light, the stopping potential reduces. Think, is assertion first of all correct? In photoelectric effect, if you increase the intensity of light, the stopping potential increases. I think assertion only is wrong, because stopping voltage is independent of it. So assertion is 100% wrong. So assertion is false. So there is only one option like that, where assertion is false, because everything else, assertion is true, assertion is true, assertion is true. So directly B option, but just for our satisfaction's sake, we'll check the reason. When you increase the light's intensity, more electrons are emitted, provided the frequency is greater than the threshold frequency. This is obviously right. This is nothing wrong. More intensity, more electrons, more current. So reasoning is true, but it is not explaining, because assertion itself is false. So B option is the right answer. Yeah, very good. Excellent, guys. Proud of all of you. Yeah. Amazing, amazing, amazing. Very nice. Let's go. Oh, now we are coming to wave particle duality. Are you loving this practice session? Yes or no? Put some fire emoji quickly in the chat box, or hearts, or smash that like button in case you haven't done that yet. Yeah, loving this problem solving session. So many models. It feels like like entire chapter we are solving it. Otherwise, imagine you sitting and solving these questions. You will feel lazy. You will feel like, no, let me not do it. Okay, I think I know it. Oh, I'm feeling bored. I'm getting stuck. How this is done? you will get distracted, you will sleep off, or you will get some message, notification. Now you are bound to watch this class because you know that if you sit here, you are solving the questions. There is no doubt about it. Very good, guys. Yes, perfecto. Let's go now to wave particle duality. Which of the following cannot be explained by wave theory of light? Wave theory of light. Refraction of light, Huygens principle, wave theory, you can explain it. Reflection, Huygens theory, you can explain it. Diffraction also is interference only at the end of the day. Crompton effect. No, guys. That is particle nature. So, yes, it is D option, which is Crompton effect. Very good. Yeah. Crompton effect, which has scattering of photons by electrons, where the photon loses the energy and scattered. So, there is light which is falling on those matter particles and it deflects here and there. So it says Crompton effect. So it has interaction with matter. So it is basically particle nature. Yeah, cool. Let's go to the next question coming up on your screen. A subatomic particle of some mass has some speed. A matter wave of that wavelength will behave like which particular electromagnetic wave? Oh, that means I need the wavelength by which I can decide. So two chapters combined together, EM waves and wave particle duality. Because if you get the wavelength, still you need to know which wavelength has similar values in electromagnetic spectrum. Now, de Broglie wavelength is the Planck constant by mass into velocity, which is momentum. So H value is 6.63 into 10 to the power minus 34 divided by the mass, which is 2.21 into 10 to the power 6, and velocity is how much? Sorry, mass is not this. This is velocity. Mass is 10 to the power minus 30, guys. So 2.21 with 6.63 goes 3 times. So 3 into 10 to the power minus 34 divided by this plus 6 and minus 30 will become minus 24. So this will become 3 into 10 to the power minus 10, which is 3 Armstrong. This Armstrong itself gives away everything. It's basically X-rays. It's basically X-rays, guys. Yeah, isn't it? It is X-rays. So X-rays is option A. Yeah. So you should approximately know infrared will be more than 700 nanometers, but it will be in maybe few thousand nanometers, not more than that. Okay. Gamma rays are very, very small. It is in 10 to the power minus 15 meters. Visible is 400 to 700 nanometers. So if you know this approximate range, you can easily get it. Yeah. Okay. Perfect. Let's move to the next one on your screen. Here it is. De Broglie wavelength of an electron accelerated by 0.1 kilovolt is how much? Oh, this is a formula. Okay, de Broglie wavelength is asked. Now the de Broglie wavelength is h by momentum, and the momentum is root of 2 times mass times kinetic energy. But you can also write the kinetic energy of an accelerated charge particle as charge into the voltage difference. But substituting all these values is a headache. Instead, for an electron, these values, if you substitute h, m, charge, everything, yes, you should know the answer 1.227 divided by root of delta V, and the final answer is in nanometers. This formula, if you know, then you will avoid this lengthy calculation. You will avoid this lengthy calculation. So let's substitute. Okay, so 1.227 divided by root of voltage 0.1 kilovolt. So 0.1 into 10 to the power 3, which is 10 to the power 2 now. Root of 10 to the power 2 is just 10. This will be nanometers. So this will be 0.1227 nanometers. So 0.1227, which can be rounded off to 0.123 nanometers. 27 is close to 30. So 0.123 is the D option. Yes, there you go. So avoid lengthy calculations if you know direct formulas. So there are some shortcut formulas for certain objects which are always asked. Like for electron, you should know this. Proton, there is no formula which you need to remember. There you have no other option but to sit and calculate. But yeah, so usually they will ask you questions on these electrons. Yeah. If you didn't know this, please remember this. This is standard, guys. I have taught this in modern physics, by the way. Yeah, I always teach this in modern physics. So please remember this formula. For electron only, if it is alpha, proton, some random particle, you have no other choice but to put this and do the lengthy calculation. Okay, moving on to the next question on your screen. Linear momentum is changed by P naught, then the de Broglie wavelength associated with the proton changes by 0.25%. Then the initial linear momentum of the proton is how much? Very, very interesting question, guys. Very, very interesting question. So the linear momentum is changed by P naught, then the de Broglie wavelength changes by 0.25%. So what is the linear momentum? See, guys, let's say my de Broglie wavelength first is h by p1. Second time it will be h by p2. It is clearly mentioned the linear momentum has been changed by p naught. So from here p1 will be h by lambda 1 and p2 will be h by lambda 2. If you take the difference of these two, so P2 minus P1 is h by lambda 2 minus h by lambda 1, and this P2 minus P1 is P naught is given by h common 1 by lambda 2 minus 1 by lambda 1 right over here. Now, as per this, the wavelength has changed by how much? 0.25%. So I think it might not be 0.25%. It could have been maybe 25%. I'm not really sure. Let's see. Okay, let's figure it out. Now, what do I do over here? 0.25%, guys. Well, it is as good as saying lambda 2 minus lambda 1 divided by lambda 1. Okay, if you multiply it by 100, that is basically 0.25. That is the meaning of it. The change in the wavelength upon the original wavelength into 100 is 0.25. Okay, so from this we will get lambda 2 minus lambda 1. Okay, divided by lambda 1 is 0.25, which is 1 by 4. So this multiplied by 100. So that is 1 by 400 right over here. So now from this we can write down lambda 2 by lambda 1 minus 1 is 1 by 400. So we can say lambda 2 by lambda 1 is 1 plus 1 by 400. 1 plus 1 by 400. Can you see that? 1 plus 1 by 400, which is 401 by 400. So from this we'll get lambda 2 as lambda 1 into 401 divided by 400. Now use this over here, we will get something. So what do I get? Instead of h by lambda 2, I will write it as h divided by 401 lambda 1 into 400 will go on the top minus h by lambda 1. Now I can see h by lambda 1 is common. So h by lambda 1 as it is, and we'll have 400 by 401 minus 1. This is P naught. Now, guys, just do one small thing. What is this h by lambda 1? This is actually the momentum initially. This is P naught. This number will become 400 minus 401, which is, you can say, minus 1, and this is 401 approximately. But I'm interested in the mod values, so let's not go into the absolute numbers. So P1 will be 401 multiplied by P0. So it's roughly 400 times. It's roughly 400 times of the P0 approximately. Yeah, that is the correct answer. Is that clear, guys? We are not interested in the negative values. Yeah. So that is option C. So don't worry about that negative sign because I do not know whether I have, uh, taken the subtraction properly. So maybe somewhere I had to take P1 minus P2 instead of P2 minus P1. So maybe because of that. So don't worry about that negative signs. Just take mod values. That's all. No, it cannot be negative. So I'll tell you where the calculation mistake has happened. I have taken lambda 2 minus lambda 1. Actually, it should be lambda 1 minus lambda 2 because when momentum increases, wavelength decreases. So technically, this is not lambda 2 minus lambda 1. It is the mod of that. So here, actually, there is a negative sign. So because of which I have got a negative value. So don't get scared by that negative sign. Okay. That was the main issue why we got the negative sign. Got it? Momentum increases, wavelength decreases. So actually lambda 2 should have been less. So ideally lambda 1 minus lambda 2 should have been put over here. Cool. So don't worry. In exam also, if you get negative sign, don't get scared. Where did I do that mistake? X minus y, I should have written y minus x. Don't worry, man. You just had to, magnitude will be the same. No, sign is wrong. No issues. Solve the problem. Okay. Don't waste your time figuring out where you had to put that negative sign. It's a waste of time. De Broglie wavelength of an electron having energy E is lambda. The kinetic energy of that electron becomes 1/4. Then the de Broglie wavelength will become how many times? Now, de Broglie wavelength is related to the energy by this formula root of 2mk. Okay, 2mk. That is what it is. So you can see it is clearly inversely proportional to the root of the kinetic energy. So therefore, I can say that de Broglie wavelength final by initial will be K1 by K2 whole thing under the root. Now the old and new kinetic energy. First energy was E, next it is E by 4. Old wavelength was lambda, so lambda 2 by lambda will be E cancels, root of 4 is 2. So therefore lambda 2 will be 2 times of lambda. 2 lambda is B option, which is IIT Bombay. Perfect. There you go. Is that clear, guys? So this formula you should know. H by momentum. Momentum is root 2 mk. K is your energy, kinetic energy. So lambda is inversely related to kinetic. So the ratio will be inversely related to the root of it. That's it. Substitute the values, you get the answer. Straightforward, guys. Shall we go ahead to the next one coming up on your screen? Ready for it? Here we go. If the de Broglie wavelength is 2 nanometers, kinetic energy is how much? Approximately mass of the electron is already given. I'll tell you what, don't have to use these values. Use your common sense. I just gave it to you. That de Broglie wavelength is 1.227 roughly. Oh, but that was for voltage by which it was accelerated. We cannot use that. Here it is not about voltage. Here it is about kinetic energy. So we have no other option but to sit and calculate, guys. So sorry, no other option. 2mk, no other option. Kinetic energy is asked, so square both sides. So lambda square is h square by 2mk. Therefore, kinetic energy will be h square by 2 lambda square m by 2 lambda square m. Now substitute everything literally. H value is 6.6. So square it into 10 to the power minus 34 square will become minus 68 divided by 2 multiplied by lambda square. Lambda. Where is the wavelength? 2 nanometer. So 2 square is 4. Nano is 10 to the power minus 9. So it will become minus 18 multiplied by mass. Mass of the electron 9 into 10 to the power minus 31. But be careful, this answer will come out in joules. So in order to convert it into finally electron volt, you need to divide it with 1.6 10 to the power minus 19. So now the calculation setup is right to get the answer in electron volt. Roughly, how much are you getting? Come on, guys. See the math. Do it. Yeah. Yep. 8 erased. Where 8 erased? We can't use, sir. Yes, yes, we cannot use. So, 11, 12, one shot in January. All right. Nayan, Kanti, you can also watch my Zero to Hero series, which I had conducted 2, 3 years back. Those one shots are also good. But yeah, we will be doing these revision classes because I'll tell you one thing, a preparation for JEE Mains has changed from last year because it's no longer easy. They're asking good questions. They're asking problem solving, statement based, assertion reason, match the following, incorrect, correct, calculation based questions. So that is why I am more focused right now on problem solving, especially for physics. Because if it was easy paper, then I can revise the theory again and again, again and again, and you will also feel happy because it is very easy also for me. But problem solving, it takes time. I have to collect good problems. You have to solve, and usually people don't like solving problems. They feel, oh, I can do it. I just need to do the theory. That is wrong. Okay, and if you just do PYQs also, that is not good. You have to do PYQs, but you have to practice variety of questions. So very, very important, guys. Yeah. Numerator, okay, 68, okay, whatever. Just see if the answer comes out 0.38 electron volt. So the final answer should come out to be 0.38 electron volt. Okay, because you have to convert it into electron volt. Yes. 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 Perfect. 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 Okay. So h square 60. Yeah, it was 68. I think I erased something. Yeah, 68. Yes, 8 was there. I think while erasing something or that 8 got erased. So it was minus 68. Minus 34 square is minus 68. Yeah, it is minus 68 only. Correct. Nothing wrong. Yeah. Cool. Shall we go ahead? Next question. Paka? Okay, here we go. The calculation is done here. Same thing for your reference. Lambda and K, de Broglie wavelength and kinetic energy graph is plotted. The correct graph is how? Oh, but be careful. There is a catch. Lambda is on x-axis, but it is 1 by K which is on the y-axis. Be little careful. So lambda is h by momentum, which is h by root 2 mk. Interesting. And 1 by k versus lambda is asked. Okay, 1 by k versus lambda is asked. Okay, what are you going to do, guys? What are you going to do? Square both sides. So lambda square will be h square divided by 2m into k. So what now? What next? Think 1 by k is equal to 1 by k is equal to 2m will go on the top, h square will come below, and lambda square will be on the top. Yeah, just check this out. Now, if I compare it, 1 by k is my y-axis, lambda is my x-axis. So this is like saying y is equal to some constant into x square. Guys, this is a parabola. Then this will be a parabola, simple. So a parabola should start from the origin and it should continuously rise. So it will be option 2 then, not option 1. My bad. Yeah, then it will be option 2. Yeah, cool. Good question. Did you love it? Yes, no. Nice question. Let's go, guys, to the next question on your screen. The de Broglie wavelength of a proton and alpha particle are lambda and 2 lambda respectively. The velocities are what? Okay, velocity and de Broglie wavelength, how are they related? See, de Broglie wavelength is h divided by mass into velocity. If masses are different and velocities are different, their wavelengths will be also different. Oh, that is the idea behind it. So the de Broglie wavelength of a proton upon de Broglie wavelength of alpha particle will be Mass of proton, velocity of proton will be here. Mass of alpha, velocity of alpha will be here. Now, for proton, the wavelength was lambda. For alpha particle, it was 2 lambda. Mass of alpha as compared to the proton is 4 times of it. Is that right? 4 times, because alpha has 2 protons, 2 neutrons, so roughly 4 times. So this will be V alpha divided by Vp. So what is the ratio of velocities is asked. So Vp divided by V alpha will be 4 by 1 is as it is. This 2 will go on the top, which will make it 8 by 1. So 8 is to 1, which is option number A is the right answer. Got it? Simple, straightforward. You should know alpha particle has 4 times the mass because 2 protons, 2 neutrons. You study that even in, what do you say, nuclear physics. Correct. Moving on to the next question on your screen. Proton and an electron are associated with same de Broglie wavelength. The ratio of their kinetic energies is same de Broglie wavelength. Kinetic energy, how is it related? Lambda is h divided by root 2 mk. Now, de Broglie wavelength is same. Ratio of the kinetic energy is asked. So h is same, lambda is same, 2 is same. So it's obvious m into k is basically the same. M into k is basically the same. Is that right? So if you ask me, the mass of proton into kinetic energy of proton will be mass of electron into kinetic energy of electron. So kinetic energy of proton by kinetic energy of electron will be mass of electron by mass of proton. Now this ratio is a standard number, which is 1836. Mass of an electron is 1 by 1836 of a atomic mass unit, or roughly the mass of proton. So you study this in atomic structure. So hence this should be the ratio 1 by 1836. That is the answer, guys. Is that clear? Yep. So 1 is to what is it? See, this ratio is basically 1836 is to 1, if you think about it. So this will be the right answer, which is option number C. Cool, guys. Everybody with me? Proton by electron, that is, if it is asked. Moving on to the next question on your screen. Here it is. A proton electron with same de Broglie wavelength, Kp and Ke are given, then which of the following is correct? Just now we solved it, but they have asked to compare. We just now solved what? Kp by Ke from the previous question was 1 by 1836. From this, isn't it obvious Kp is less than Ke? Kp is less than Ke. So it should be option C, guys. Is that understood, everyone? Directly we can see that Kp is lesser than the value of Ke. Perfect. There you go. Amazing, amazing, amazing. Moving on to the next question coming up on your screen. Here it is. Try this out. Proton, electron, alpha particle, same energy. The de Broglie wavelengths will be how? How are you going to compare them? Lambda is h by root 2 mk. Their energies are same. H and 2 is constant. So lambda is inversely proportional to root of mass, which means somebody has more mass that will have lesser wavelength. As simple as that. So between proton, electron and alpha particle, I know for sure that mass of alpha is the highest, then comes proton, then comes electron. So therefore, for the wavelength, it will be exactly opposite: lambda alpha, lambda p, and lambda e. So lambda e will be the highest, then lambda of p, and then lambda of alpha. So lambda e, lambda p, and then lambda alpha. I think that is option number B right over here. There you go. Yep, perfect. Yes, B for IIT Bombay. Yeah, very straightforward question, just direct comparison. Yeah, very simple only. Moving on to the next one. If there is a proton and there is an alpha particle, same voltage you accelerated, then the ratio of the de Broglie wavelength. This kind of question also come, accelerating it. And de Broglie wavelength, I know it is h by root of 2 mk. This same kinetic energy, after acceleration, it comes charge multiplied by the voltage by which it has been accelerated. H2 is same, voltage is also same, so wavelength is directly proportional to 1 by root of mass multiplied by charge. Now proton and alpha particle, you just have to find the ratio of it. So let's try it out. Lambda of proton by lambda of alpha will be, root will be there, okay, root will be there. You will have mass of alpha, mass of proton here, and root will be there, charge of alpha and charge of proton will be there. It's inversely related to the roots. Alpha has 4 times mass of proton. Charge wise, it is just 2 times, 2e versus e. 2 protons will be double charge, 1 proton is single positive charge. So root 4 is 2, so 2 root 2 will be the answer. So 2 root 2 is option C, guys. There you go. Simple, everyone? Yeah. Root 2 root 2. Yes, amazing, 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 amazing. Yeah. Tell me frankly one thing. It's almost 2 hours now since we started the class. How many of you would have actually sat and solved on your own problems till now without getting up? Many kids are there from the beginning. I can see that. How many of you would have actually sat without distraction, without giving up, without taking a break, without giving any excuses? Yeah, we're not taking a break right now, just telling, asking. Yeah. So that is very important, guys, that some of you would have given up. So that is the whole purpose. But I want to see how many of you will sit till the end. And that is your true motivation level then. Moving on to the next question on your screen. De Broglie of a molecule of a gas is the lambda 1 at 300 Kelvin. If the temperature is increased, what happens to the de Broglie wavelength? How is de Broglie wavelength related to the molecule of the gas? See guys, that molecule will be moving. It will have some speed. That means it has some momentum. Hence, it has some de Broglie wavelength associated. And this speed has a relation with the temperature. And what is that relation? We all know whether it is RMS speed, average speed, most probable speed, it's always directly proportional to the root of temperature. So V is directly proportional to root T, and our de Broglie wavelength, that is inversely proportional to velocity, because de Broglie wavelength is nothing but h by mv. So it is inversely proportional to velocity. So in a way, can I say it is indirectly proportional to the root of temperature, de Broglie wavelength? Indirectly. So can I just say the lambda 2 by lambda 1 will be nothing but root T1 by root T2, which is first temperature 300, next temperature 600. So 1 by 2, so 1 by root 2. So therefore, my new de Broglie wavelength will be lambda 1 divided by root 2. Lambda 1 by root 2, which is C option. Wow, why is C or not this, guys? It should be this particular option. Just check this out, 300 to 600, right? Perfect. Yeah. So it should be C option. Yes, very good. Very good. Many students make this mistake of forgetting the concept of speed and temperature, which was there in kinetic theory of gases. Beautiful question, guys. I think you should know these kind of questions can come in the actual examination. Next one coming up on your screen, and here it is. Proton has same energy as that of a photon. Proton has same energy as that of a photon of wavelength lambda. Okay. The proton is moving at a non-relative speed. Then the ratio of its de Broglie wavelength to the wavelength of the photon is interesting. Okay. Let's start by solving it for proton. Has same energy and wavelength is lambda. So essentially, lambda is h by root of, or basically h by momentum, which can be written down as h by root of 2m into energy. This is for proton. Now let us write down for photon having the same de Broglie wavelength. We know energy is hf, which is hc by lambda. Okay, the ratio of the de Broglie wavelength is asked. So if I call this as lambda 1, then this should be lambda 2. Therefore, lambda 2 will be hc divided by E. Now we have to take the ratio of both of them. So lambda 1 by lambda 2 will be lambda 1 has h by, what is there over here? H by u, h by root 2me. What does lambda 2 have? Lambda 2 has hc divided by E. What and all is getting cancelled? This h and this h. This root E will cancel with this and it will become root. So we should get the final answer as 1 by C outside, root E is on the top, and 2 times of M. 1 by C, 2E, E by 2M. E by 2M, that is the D option. Yes, D option. Perfect. Perfect. Got it, guys? How to solve this question? Very good. Very good. Very good. Next one coming up on your screen, the de Broglie wavelength of an electron is same as that of a photon if the velocity of electron is 25% the velocity of light. The ratio of their kinetic energy of electron and the photon will be. Interesting question. Let's do this one by one. The de Broglie wavelength of an electron is same as that of a photon. And if you just talk about the photon, the energy is E, assuming I can say it is hc by lambda. Now, if I write for the electron, the velocity of the electron is 25% the velocity of the light, then the ratio of the kinetic energy of the electron to that photon. Okay, so first of all, let me call this as energy 1. And next thing which I need to do is energy 2 for the electron, which is p square divided by 2m. Momentum is nothing but h by lambda. So square it. So this will become h square divided by 2m lambda square. Now I will need this over here. I feel this is my energy 2. But there is one more information given to me, that the velocity of the electron is 25% the velocity of the light. That will help me solve another part. Instead of writing p square by 2m, how about me writing this as half m v square, where the velocity is c by 4, and square it. So this will become mc square. 4 square is 16, 16 2s are 32. So that is basically your second energy. But I can see if I divide both of them, I'm not really going to get any number ratio. So many students get stuck in this loop. What happens? Many students will get stuck in this particular loop that now we are not able to proceed. What to do, sir, now? I'll tell you one simple way of solving this dilemma. Forget all this, okay? Because this will just take you inside a loop. The energy for the photon is hc by lambda. Energy of the photon is hf or hc by lambda, normal thing. Now, if you do it for the electron, the de Broglie wavelength is given by h by mass into velocity. Now, we can do one thing. This mass into velocity, because mass is not there in the answer and I can't cut it out, I can write mass into velocity as half m v square. Observe this. because this part is kinetic energy. Because one extra V came, I have to divide it with V. And because an extra 2 came, I have to multiply it with 2. So it will become 2 by V. So won't this become H by, this is the energy of the electron. So I can call it E2 multiplied by 2, and that V will go on the top. So that will become your lambda. That will become your lambda. And from the first equation, my lambda is Hc by E1. So lambda is the same de Broglie wavelength is given. So if lambda is same, therefore I can say Hc by E1 will be equal to Hv by 2 times of E2. Okay, I just equated lambdas. So right hand sides will also be equal. H will get cancelled. And let's see what are we left with. I have C divided by E1 over here. And on the right hand side, velocity is speed of light 25%. So C by 4. So this is 2E2. CC cancels. So therefore 1 by E1 is equal to, this will become 1 by 8 times of E2. So E2 divided by E1 will be 1 by 8. So electron by photon is 1 by 8. So 1 by 8 is C option, which is absolutely correct. Got it? So just had to make sure that the mass is out of the picture, because in the ratio mass is not there. So to get rid of mass, I did this manipulation. I multiplied by 2 and divided by V. Otherwise, everything else, like I was trying to show that to you when I think I got disconnected, whatever else you do, mass will always remain. Okay, so this is a very good problem on how to get rid of mass when kinetic energy and momentum are involved. Okay, cool. A very similar question, I have kept it as homework. De Broglie wavelength with speed C by 3 instead of C by 4 is there. Their de Broglie wavelengths are equal ratio of the energies. Will you now be able to solve this question as homework? Yes or no? If you just use kinetic energy formula, the problem is half mv square, mass is not known. So again, you have to write it as p square by 2m. Again, m will come. So whatever you do, mass will always end up remaining. So that is why the manipulation that you need to do is momentum, write it in terms of velocity and kinetic energy. So that is the correct way, because anything else will still keep your answer. Momentum is m into v, which is half mv square divided by v multiplied by 2. So that is kinetic energy by velocity. So momentum is kinetic energy by velocity. That is the manipulation that we have done over here. Okay, got it? I'm pretty sure now this approach, you will remember it if such a question comes in the examination. Let's go to the next one. A photosensitive material is illuminated with wavelength lambda 1. So it releases electrons with de Broglie wavelength lambda 2. The longest wavelength that can emit a photoelectron is lambda naught. The expression for the de Broglie wavelength is. Actually, this is a very straightforward question, but if you look at the options, now everybody will get scared. I'm not sure if it is visible so clearly or not, but if it is not, I'll just probably remove the light. Maybe you can see it now. So actually, it is based on the photoelectric energy equation. Energy of our photon is work function plus maximum kinetic energy. This is the exact equation you start off with. Okay, and then you will see, you will get the answer. How? Let me show it to you. Energy of the photon. Light of wavelength lambda 1 is falling, so this will become hc by lambda 1. The maximum wavelength which can create photoelectric effect is lambda naught, so this is threshold. So phi will be hc by lambda naught. Kinetic energy is related to your de Broglie wavelength like this. De Broglie wavelength is h by root 2 mk. So therefore, lambda de Broglie square is h square by 2 mk. So therefore, kinetic energy is h square by 2m lambda d square. So this formula if you use, our kinetic energy will be h square by 2 times mass times de Broglie wavelength. The de Broglie wavelength is lambda e as per the given question, de Broglie wavelength. So now it becomes easier to solve. H, and one of the H gets cancelled. And what is really asked in the question? The expression for the de Broglie wavelength. That means this is asked. So take these two. So C is common. And you have 1 by lambda 1 minus 1 by lambda naught is H divided by 2m lambda E. Yeah, is that right? So rearrange it further. Lambda E will be H by 2m. C will come below and this will go also below, which is 1 by lambda 1 minus 1 by lambda naught. So that's it. So that should be the answer. But oh, 1 second, this was square, right? So this was also squared. So even this will be also squared. Even this will be also squared. Yeah. So square term was missing. I just added it over here. So if this is squared, the root of this should be the answer. H by 2 mc, 1 by lambda 1 minus 1 by lambda naught. So C option. Yeah. Directly. You can see this is exactly the answer which you wanted. Cool. So the final answer will be lambda E will be root of H is in the numerator divided by 2 times M into C, 1 by lambda 1 minus 1 by lambda naught. If you are not able to see the option clearly, I am rewriting it over here for all of you. Okay, cool guys. Nice question. Shall we go ahead? Here it comes. Next question on your screen. Electron of mass m and charge E at rest gets accelerated by a field of 2e. The rate of change of de Broglie wavelength versus time, ignoring relative effects, is how much? Wow, it's interesting. Yeah, you'll be getting a break after this. Yeah, before we go to atomic structure, we are going to get a break. Don't worry. The rate of change of de Broglie wavelength. What is de Broglie wavelength? De Broglie wavelength, we know, is h by mass into velocity. But what is velocity? Velocity is initial velocity plus acceleration multiplied by the time. But what is acceleration? It is nothing but force divided by the mass, so multiplied by the time. What is the force? Force is charge, which is E, multiplied by the field, which is 2E. Force multiplied by the charge. Remember electrostatics? Remember electrostatics, guys? Yes, exactly. So charge into the field will give me the force divided by mass into time. That is velocity. So substitute that here. You will see in the denominator now you will have 2e e t and numerator will have m, and this is h by m is lambda. So rearranging further, what do I get? mm gets cancelled, h by 2ee, and this will become t raised to minus 1. Why did I do it? Reason, take the derivative on both sides. Rate of change of de Broglie wavelength, h by 2ee is constant. It will become d by dt of t raised to minus 1. So it will become h by 2ee. This will become minus 1 into t raised to minus 2, which is negative h divided by 2e e t square. So negative h divided by 2e e t square, which is option A. There you go. Perfect. That's the answer. So derivatives was there. Many people get confused. What is this rate of change of de Broglie wavelength? Sir didn't teach it. Obviously, sir, no sir will teach you. But you have to use your brain. If I know the formula, taking the derivative will give me d lambda by dt. So application of derivative is directly. Got it? Everyone? Perfecto. Nice question. All right, let's go to another question coming up on your screen. Electron with mass m and initial velocity enters the electric field. This is the value. The initial de Broglie wavelength is lambda naught. The value after time t will be how much? Interesting question, guys. Very, very nice question. Electric field, be careful, is not in I cap, it is in negative z direction. So what will that electric field really do? This will apply a force, and that force will be charge into the field. So it will be minus electron into E naught, and that will be k cap. So that will give me an acceleration which is minus E by m E naught into k cap. This acceleration being in the z direction, it will only create z velocity. Now keep that in mind. Initially the velocity was in I cap Vx square plus Vy square plus Vz square. There is no velocity in y, so forget it. Vx is nothing but v naught, so 0 square plus e by m into t. Even though it is negative, after squaring it will become positive. So I'm going to get v naught square plus e by m into time and whole square. That is your velocity. So from this you will get your de Broglie wavelength, which is h by momentum. So h by m is there, and this entire velocity term is also going to be there, which is v naught square plus e by m into t and this whole square. So that is the answer. Is that okay? So what will match? But wait a minute, there is a small catch. There is V naught which is taken outside and all of that, and because of which things will change. Yeah, so you need to be careful. So what we need to do over here? Okay, I'll go to the next page because we need that space now. Okay, now you have to take V naught also outside. It's not so simple. It's not done because I can see none of the options are matching yet. So H by M is there. You take V naught outside like this, and inside what will be remaining is 1 plus E by M tau, no, time divided by V naught and this whole square. Just check this out. Is that right, everyone? Akka? Yes. Till this point, absolutely clear. Till this point, absolutely clear. Okay. Why did I do it? I'll tell you why. This H by V naught, which you see, just concentrate on H by, sorry, MV naught. This is initial de Broglie wavelength. So H by initial momentum is technically lambda naught. Rest everything is as it is. So lambda is there. Okay. And this entire thing divided by 1 plus EET by MV naught and then square. So that gives me this option C. There you go. Perfect. This is exactly C option. So beautiful manipulation, as you can see, from force, acceleration, kinematics, Newton's laws, okay, kinematics in 3 dimension, vectors, magnitude, de Broglie wavelength, electrostatics concept, mathematics also, everything is there in this question. This question will scare most of the kids. They will leave it, but actually it is very methodical. So I feel it was a very good question. Yeah, I feel, yeah, perfect. How they have combined it with multiple chapters. So, it's not easy to say that you can leave certain chapters like mechanics. Photons of so energy are incident on a material. The de Broglie wavelength emitted with maximum energy is 10 Armstrong. The work function is how much? Photons of energy is given. So energy of the photon is work function plus kinetic energy. Photoelectrons with maximum energy is 10 Armstrong. Okay, energy of the photon is given, so 8 into 10 to the power minus 19, but let's convert it into electron volt by dividing it by 1.6 10 to the power minus 19. Work function is asked in electron volt, so everything I'm keeping it in electron volt. So kinetic energy, how do I find from de Broglie wavelength? Okay, so the photoelectrons de Broglie wavelength is 10 Armstrong. So lambda is basically 1.22, you can say, but that will be for voltage difference. We cannot do that. So lambda will be h by root of 2mk, squaring both sides, lambda square is h square by 2mk. So kinetic energy is h square by 2m lambda square. This answer will be in joules. So this kinetic energy, if I want it in electron volt, right now this was in joules. Whatever answer I got, this was in basically joules. If I want it in electron volt, then you take this h square by 2me lambda square. Then whatever answer you will get it in electron volt if you divide by E. So just take the same thing and do it over here. H square means 6.6 into 10 to the power minus 34 whole square, whole thing divided by 2 times mass of an electron 9 into 10 to the power minus 31, electron charge 1.6 10 to the power minus 19, and de Broglie wavelength was 10 Armstrong, which is nothing but 1 nanometer. Is that right? 10 Armstrong is nothing but 1 nanometer. So 10 to the power minus 9 meters, but square it because there is square over here. Solve this, you will, by the way, this answer is also in electron volt. So finally answer that you will get will also be in electron volt. Okay, the calculation part I have kept it over here. So I think you should get close to 3.5 electron volt. So try this. It was just a calculated question, but you should know how to do that method. That is very important. Yeah. Okay, perfect. So I think we should have a break time now. Yeah, we'll be resuming shortly, guys. Right now it is 5:40. Let's meet at 6 o'clock. We'll take a 20 minutes break and we'll meet at 6 o'clock. After that, we are going to start off with atoms, atomic structure, and atomic spectra. So we'll start with that. Cool? All right. See you at 6 o'clock then. Good evening, good evening. Let me know if I'm audible and visible to all of you. Yes, we are back. The time is up. I hope I'm audible. Good evening, good evening. Yes, we just completed wave particle duality, dual nature, photons and photoelectric effect, questions from modern physics. A lot of questions were done. I don't know the exact count, but I'm guessing around 30-40 questions were already done, or maybe 150. So now it's time to move to atoms, atomic structure, and atomic spectra. Okay, ready for the problems, guys? Perfectly audible. Good evening. Okay, so get ready, guys. The questions are going to start. Okay, going on the sequence. Here comes the first question coming up on your screen. Statement base. Most of the mass of the atom and all its positive charge are concentrated in a small nucleus, and the electrons go around, is what Rutherford said. Atom is a spherical cloud of positive charge with electrons inside embedded, is a special case of Rutherford model. What do you think is the right option over here? Very nice question. Think about it and give me the correct answer in the chat box. Oh, just now completed lunch. That's quite late, man. Okay. So make sure you guys maintain your health, eat on time, because the same thing will continue. You might have repercussions on the exam day. So follow the same schedule which you are going to do. If you are eating lunch very late, then make sure you are eating it every day late. Okay? Yes, the correct answer is option number B. Statement 1 is true, statement 2 is false. This was exactly Rutherford's model, where most of the atom is empty, the nucleus is a dense, positively charged mass. Most of the mass is there, and electrons, teeny mini masses, revolve around it in most of the empty space. So that was correct, nothing wrong about it. But this is wrong. Electrons embedded is not Rutherford's model, that is Thomson's model. That was Thomson's model. Yeah, is that right, everyone? Very good. Yes, amazing, amazing. Yes, somebody said it. Who was that? Pondi Tamilian. Yes, perfecto. Moving on to the next one coming up on your screen. The dimension of Planck's constant and angular momentum are same. Bohr's model revolves, the electron revolves around the nucleus only in those orbits for which angular momentum is integral multiples of Planck's constant. What do you think? Well, Bohr's model, angular momentum is integral multiples of Planck constant. No, it is nh by 2 pi. So I think second statement is wrong. Lot of people make this mistake. They forget that 2 pi is also there. Yes, see, already you wrote option A. No, guys, statement 2 is wrong. Statement number 2 is wrong. Be careful. And angular momentum and Planck constant, are their dimensions same? Let's think. For Planck constant h, it is energy divided by frequency. So it will be m raised to 1, L raised to 2, T raised to minus 2. Whole thing divided by frequency means T raised to minus 1. So it is going to become m1, m1, L2, T raised to minus 1. That is the dimensional formula for Planck constant. What is the dimensional formula for angular momentum? Angular momentum, it is mvr. So m raised to 1, velocity is length raised to 1 by t raised to 1. Distance is l raised to 1. So it will become m raised to 1, l raised to 2, t raised to minus 1. Clearly both of them are equal. So statement number 1 is correct. But second statement is wrong, guys, because it is integral multiples of h by 2 pi. Yeah, the 2 pi, how can you miss? Got it? Okay, let's go to the next question on your screen. Assertion reason. Bohr's model is applicable to hydrogen and hydrogen-like atoms only. The formulation of Bohr's model does not include repulsive force between electrons. In the light of the above statements, what do you think is correct? This is obviously correct. Bohr's model was applicable to hydrogen atom and single electron atoms, which means hydrogen-like atoms. And why is the reason? Because we neglect repulsion between multiple electrons. Otherwise, our entire derivation fails. Where we take a force centrally acting towards the nucleus, there will be multiple forces from multiple electrons, which will cause some problem. So this is also correct and it is explaining it properly. So assertion and Reason, both are true and it is the correct explanation. So it is B for IIT Bombay. Yeah, it is B for IIT Bombay. Very good. Helium double plus, lithium, yes, helium plus and lithium double plus. Arivasu, be careful. Hydrogen like means helium single plus. Double plus means both electrons will go away, nothing will be there. So hydrogen like means helium plus, lithium double plus. Lithium has 3 electrons, 1 electron should remain back. Yeah, got it? Okay. Let's go to the next question on your screen. For Bohr's theory, the moment of the momentum means angular momentum in the fourth orbit is how much? So moment of force is torque, moment of inertia is I, moment of momentum is angular momentum is n h by 2 pi. N is 4, so substitute the value of n as 4 into h by 2 pi. 4 and 2 cancel, so 2h divided by pi is the answer. 2h by pi is option A for IIT Abu Dhabi. Wow, what a question. Very direct question. NH by 2 pi. Amazing. Pondhi, Savita. Very good. Ritesh, no, it's not B, it's A. Yes, Ibu. Yes, Harni. Very good, Arivasu. Very good, Kalyani. Yes, A for Apple. A for IIT Abu Dhabi. Yes, let's go, guys. Next answer. Next question. Consider Bohr's model. The ratio of fifth orbit to the fifth orbit of lithium double plus and helium plus is how much? Ratio of the fifth orbit for lithium double plus and helium. In Bohr's model, the radius is directly proportional to n square by what? Z. N is the same, so indirectly R is inversely proportional to Z. So radius in lithium upon radius in helium will be Z of helium on the top and atomic number of lithium over here. So that is 3 and this is 2. So there you go, 2 by 3, which is very simple and straightforward. Option B. Yep. So n was same. If n was different, then it would be still a better problem, but n was exactly the same. Okay. Moving on to the next question. Assuming the validity of Bohr's model for hydrogen-like ions, the radius of lithium double plus ion in its ground state is given by 1 by x a naught, where x is how much? Assuming the validity of Bohr's model, the radius of lithium double plus ion in its ground state is 1 by x a naught, where a naught is the first Bohr's radius. So what is the value of x? See guys, in general the radius is given by Bohr's radius, which is, let's say for example, a naught into n square divided by z. Now we are talking about the radius of the lithium double plus ion in this ground state. Ground state means n is 1. Lithium means z is 3. So this will be a naught by 3. This 3 is exactly what you need, x. So it should be D option. It should be basically D for IIT Delhi. Perfecto, Kalyani. Ibu, very good. Harni, Kalya, very good. Very good, Rishik. Anjali, perfect. You guys are fast. Amazing. Keep up that momentum, guys. Let's go to the next question on your screen. The frequency of revolution of electron in the Bohr's orbit varies with the principal quantum number as frequency. How will the frequency change? Frequency is 1 by time period, and time period is circumference, which is 2 pi r by velocity. Time is distance by speed, so circumference by speed. Now velocity is some constant into z by n, whereas radius is Bohr's radius into n square by z. So if you rearrange it, it will become v naught by 2 pi r naught. Z and z will become z square, n and n square will become n cube. So our frequency will become inversely proportional to the cube of n. So inversely proportional to the cube of n, that's C for Captain Shreyas. This was very important, this transition which I did. So the time is the distance by our speed, and that distance is the circumference, which is 2 pi r, and the speed with which it goes is v. So that's why it was 2 pi r divided by v, okay, in one orbit. Next one. Come on, my dear warriors. Figure this out. Very nice question is coming up on your screen. Let's do it. De Broglie wavelength of an electron in the fourth orbit of Bohr atom with Bohr's radius A is how much? Bohr's radius is given. They are asking what is the de Broglie wavelength. Interesting, in the fourth orbit. Okay. Now, one thing is there about de Broglie wavelength. N times whatever is the de Broglie wavelength will always be the circumference. So, if you take the de Broglie wavelength and multiply it by the principal quantum number, it will exactly fit inside the circumference. And the circumference is 2 pi r. And because we are talking about the fourth orbit, is that right? Fourth orbit, it will be original Bohr's radius into n square, which is 4 square, divided by z. Z is just 1. Okay, so here this value of n is also going to be 4 times of de Broglie wavelength. So lambda d will be 2 pi into a into 4 will cancel into 4. So it will become 8 pi a. So the de Broglie wavelength is 8 pi a. That should be the answer, which is A option. I'm pretty sure many of you make many mistakes while doing this. Either you will forget this or you will forget this 4 and you will get either 2 pi a or just 4 pi a. All these are common silly mistakes which I have seen. Yeah. So option A for Abu Dhabi. Yes, Kalani Abu. Okay. Anjali, it's not D, it's A. Yep. Perfecto. Arivasu, it's not D, it is A option, my dear. Okay. See where you went wrong in this solution. The concept over here is that if you have any orbit, then the de Broglie wavelength will exactly fit that many times as that of the orbit number. Okay, as many times as the orbit number, 1, 2, 3, 4, like that. So that is the logic behind it. Okay, keep that in mind. An electron in the ground state of hydrogen has a radius, while electron in the third excited state has this radius. The ratio of the de Broglie wavelengths is how much? Okay, so we all know n times of de Broglie wavelength will be the circumference, which is 2 pi r, which is 2 pi base radius into n square. You can say this is n times of lambda. So lambda d will be nothing but 2 pi a into n, just what we did in the previous question. Question is the ratio of the de Broglie wavelengths. Base radius is same, n is going to be different. Yeah. The electron in ground state of hydrogen is this much, has an orbital radius of this much, where the electron in third excited state is this much. So I can just see over here, oh, n I do not know in this problem, so I cannot do anything with this. So no point using this now. So no point using this. So we have to think something differently. What do we do, guys? Because radius is already given, we cannot just ignore that particular radius. What we can do, probably use angular momentum concept. Bohr's model, angular momentum is nh by 2 pi maybe, and angular momentum is mv into r, is nothing but nh by 2 pi. And what I will do, mass into velocity is nothing but momentum. Momentum is nothing but h by de Broglie wavelength into r is equal to n, and this was not lambda, this was h, right? This was n h by 2 pi. Now, obviously, this h and this h will cancel out, and what else? We will get 2 pi r divided by n is lambda d. Lambda d goes on the top, 2 pi r, and divided by n. And that is what we are asked, the ratio of the de Broglie wavelengths in the ground state upon the excited state. So ground state, that will have radius of ground, and this will have radius of excited state, and inversely proportional to n. So n of excited state upon n of ground. Now radius of the ground state is given to be 5.3 10 to the power minus 11, and excited state is 8.48 into 10 to the power minus 10. Excited state, what is it? Third excited state means it is 4. Ground means n is 1. Be careful. Third excited state means n is 4, not 3. Because first excited state means it jumped from ground, which is 1, to the second principal quantum number. So first is 2, second excited is 3, third excited is 4. So I think we can make the power same. So it will become 5.3 divided by 84.8. This will become 10 to the power minus 11, 10 to the power minus 11, and 4 is there. Both these get cancelled. I think this will be how many times? 16 5s are 80. So almost 16 times. So 4 by 16, which is 1 by 4. That is G by E. G by E. But they have asked the ratio of the de Broglie wavelength in the ground state to that of excited state is, I think they have asked inverse, if I'm not wrong. So it should be 4:1 in that case, excited by ground state. Okay, I think it will be 4:1 because I think they have missed that part. The ratio of the de Broglie wavelength of electron in the ground state to the excited state. Yeah, they have asked exactly opposite. Okay, cool guys. Shall we go ahead? Shall we go ahead to the next question coming up on your screen? Electron is going around in Bohr's nucleus, Bohr's model actually. It's going around the nucleus, positive charge is Ze, okay, correct relation between total energy and its potential energy. Standard formula. Always potential energy is nothing but 2 times of the total energy, and kinetic energy is always negative of the total energy. Standard. So U is 2E, U is 2E, which is C option. That's all. Looking at the options, you'll get confused. So such questions, don't look at the options because that will confuse you. You will forget what you had remembered. You will forget your original thinking. So always avoid looking at the formulas. Write it and then look. Then you will be sure. Then you can mark it with confidence. Yeah, I have seen this many times. People lose that confidence after looking at the options. Total energy of an electron in the second state is this much. The kinetic energy is how much? Just similar concept. Kinetic is negative of total. So it will be negative of minus 1.51. So it will be just 1.51. The total energy in the second excited state of this much is given. The kinetic energy is asked. So it will be just 1.51 electron volt, which is D option. Got it, guys? Everyone? Perfecto? Amazing? Simple? Laddu? All right, let's go to the next question, guys, on your screen. Here it is. In a hydrogen-like atom, energy between second excitation state and the ground is this much. What's the atomic number? In general, the energy formula in the nth orbit is negative 13.6 Z square by n square in electron volt. They have asked the difference between excited and the ground state. Which excited state? Second excited state means n is equal to 3. So they are given E3 minus ground state, which is E1. So that will be negative 13.6 Z square will be there. You will put 3 square here and then you will put 1 square over here. This difference has been given to be how much? 108. 108.8 electron volt. Anyways, if this is also electron volt, this is also electron volt, is minus 13.6 Z square. This will be 1 by 9 minus 1. Okay, and this electron is also there here. So first of all, this electron and this electron, so I will just get rid of it. So 108.8 is, what is it? Minus 13.6 Z square. 1 by 9 minus 1, 1 minus 1 by 9 is 8 by 9. So it will be negative 8 by 9. Now negative negative will cancel. So Z square will be 108.8. 108.8. 8 will come below. 8 will come below. 13.6 will also come below. 13.6 will also come below, and 9 will go on the top. Now, if you recollect 13 stable, yeah, 13.6, I think it will go with 108. How many times, guys? How many times? Roughly. Actually, it is going to go with 10. Yes. How much? How many times? Come on, guys. It will go with 104, but because there is 0.6, so I think it will be close enough to that. It will be 8 times over here. And this 8 and this 8 will cancel. So what will be actually left is z square is 9. So z will be 3. Because z square is 9. So z will be 3. So option C is the right answer. Roughly you can go. Yeah. You should know the tables then. Yeah. So don't have to sit and actually divide 108.8 divided by 13.6. Go roughly. Yeah. 13 8s are roughly 13.6 into 8 will be close enough to 104. So it is 108.8. That's all. Okay. Moving on to the next one. In the Bohr's model of hydrogen atom, the energy of hydrogen atom in the ground state is same as the energy of hydrogen ion in the first excited state. The energy of hydrogen atom in the ground state is same as lithium ion in the second excited state. Ground state is hydrogen ion. The ground state energy of first excited state is same as the lithium ion in the ground state. Okay. Ground state, hydrogen atom in the ground state is minus 13.6. So which other answer will give you minus 13.6 z square by n square? This is ground state. This is ground of hydrogen atom. So which other thing will give you that? This is only possible if z square is equal to n square, or basically z is equal to 1. Now if you take a helium atom, for helium atom z is equal to 2, so n will be 2. That means first excited state. If you take lithium atom, z is 3, so n will be 3, so that means it is second excited state. So which of these options will match? Yeah. Next session you want to take for complete mechanics, and I have already planned it, man. I have already planned it. Oh, but multiple options will be correct. Energy of hydrogen atom in ground state is same as helium plus ion in its first excited state. Definitely this is correct. You can see that it is over here. Hydrogen atom, lithium ion in its second excited state. Yes, that is also there over here. Second excited state. Same as helium plus in ground? No. Helium ion in its first excited will definitely not be lithium ion in its ground state. This will definitely not be true. A and B only two options can be correct. So, oh sorry, not D, this one, A and B. Okay, hydrogen atom in its ground state is same as lithium ion in its second excited state. A and B, which is A option. Is that correct, my dear warriors? Everyone? Yes, perfecto. Next session is, yes, mechanics, guys. I'm going to conduct it on Thursday. So you better come prepared. We are going to solve all the questions from mechanics, right from kinematics 1D, 2D, relative, Newton's laws, friction, circular motion, work power energy, center of mass, momentum, collisions, rotational motion, angular momentum conservation. All of these things, including vectors, of course. So yeah, that is going to be an crazy session for all of you. Let's go. Next one on your screen. Number of spectral lines which are going to be emitted by hydrogen atom in its fourth energy level. From its fourth energy level. These type of questions, rather than showing fourth energy level, then third, then second, then first, and thinking about what all possibilities can come, instead of that, what you can do is basically use the formula NC2. That's it, which is nothing but 4 into 4 minus 1 divided by 2. Here that N is 4. That's all. So 4C2. Direct formula, guys. So 4 3s are 12. 12 divided by 2 is 6. So the answer will be 6. Just use NC2 formula. You get it. Okay. Perfect. All right. Very good. Very good. Very good. Very good. Oh, you want such a session for optics also? Yeah, optics session will be very small. Yeah, we can combine maybe waves and ray optics together. Light waves, electromagnetic waves, um, then mechanical waves, sound waves, everything together, and along with the ray optics. So that I think can be a better question. Hmm, Okay, let's go, guys, to the next one coming up on your screen. A hydrogen atom in its ground state is given this much energy. How many spectral lines will be emitted due to the transition of electrons? Oh, interesting. So, ground state has negative 13.6. This is ground plus 10.2 will become how much? What is the energy of that? What will be that energy of that nth state, guys? Yeah, how much will it be? 3.4 electron volt. Why did I say 1.4? So 3.4 electron volt. Now 3.4 electron volt is for which level of energy, for which level of the shell, for which principal quantum number for hydrogen atom? Think like this. This will be nothing but minus 13.6 into z square is 1 square divided by n square. So therefore, this was also negative, by the way. Therefore, what am I going to get? N square will be minus 13.6 divided by minus 3.4, which is nothing but 4. No. Yes, 4. Correct. So basically, N will be 2. N will be 2. So I'm getting my value of N will be nothing but 2. So if this was my ground state where N is equal to 1, I'm right now at N is equal to 2. The only transition which can happen is this one. So only one line I will get. So D will be the right answer. Yes, perfect. Only one line. If this was 3, then I'll get 3C2. If this was 4, I'll get 4C2. If this was 5, I'll get 5C2. So only one line will come because nothing else can happen. Yes, N will be 2. Got it? Everyone? Perfect. Perfect. Let's go to the next question. During the transition from A to C, wavelength is 2000 and it becomes 6000 when it goes from B to C. Then the wavelength during A to B is how much? Oh, interesting. So let me show the levels. So let's say this is A to B to C. Okay. So during the transition from A to C directly, the wavelength is 2000. So energy of A minus energy of C is energy of the is hc by lambda in the first situation, which is hc by how much? 2000. hc by 2000, assuming everything is in Armstrong. Accordingly, we can change the units. In the second situation, energy between B and C, the difference is hc divided by how much? 6000 Armstrongs. 6000 Armstrongs. Last one they have asked between A and B, how much will it be? So I have an idea. If I negate this, this will become minus EB plus EC will become minus HC by 6000. So what I will do now, I will take this equation and I will take this equation, combine both of them and add them. Just add them. So EC and plus negative EC and plus EC will cancel. I'll be left with EA minus EB will be HC by 2000 plus HC by 6000. But this energy difference is itself HC by the wavelength which will be emitted. So this will be HC common 1 by 2000 plus 1 by 6000. Okay, HC will cancel. So 1 by lambda will be, okay, so this will become 3 plus 1 divided by 6000, which is 4 by 6000, which is nothing but 1 by 1500. So wavelength, is that right, guys? 3 plus 1, yep. And we have to add them. Oh, there is one catch. I forgot that minus sign, else the options will not match, guys. One second. This was not plus, this was minus. So be careful. So HC divided by 6000. Okay. So this will be 1 by 2000 minus 1 by 6000 basically. Okay. So HC will cancel. LCM is 6000. This will go 3 times. This will be as it is 1 time. So 3 minus 1 is 2. So 2 divided by 6000, which is 1 divided by 3000. So lambda will be inverse of this. So that will be 3000 Armstrong. So 3000 Armstrong is the D option. Is basically D option, not 6000. It will be 3000 Armstrong. Yes, correct. The solution also, it should be 3000 only. Yeah. 3000 is the correct answer. Perfect. Nothing wrong. Got it? So you just have to manipulate this. Make sure that 1 minus 2 is known, 2 minus 3 is known. So find out 1 minus 3. So it's just simultaneous equations, 3 variables. Yeah, perfect. Cool, guys. Shall we go ahead to the next one? Let's go. Here it comes. The ratio of the shortest wavelength to the of Balmer and Lyman series is how much? Now let's think. Shortest wavelength will always come for the largest, meaning will be when transition happens from infinity to 2, and for Lyman it will happen when you go from infinity to 1. This is your transition. So Lyman comes first, Balmer comes next. Lyman, Balmer, Bastian, all those things. So the reason for that, same thing. Energy is hc by lambda. Shortest wavelength will have largest energy difference. So now let's do this properly. Lambda of Balmer will be Rydberg's constant 1 by 2 square minus 1 by infinity square. So this will be r by 4 because 1 by infinity is 0. 1 by lambda of Lyman will be Rydberg's constant 1 by 1 square minus infinity square here. That is 0. So it is just r. So if I divide, both of them. So 1 by lambda L divided by 1 by lambda B. This is r divided by r by 4. So lambda B will go on the top. Lambda L will stay below. 4 will go on the top. So 4 is to 1, which is D option. Yes, that is right. Absolutely. So Lyman comes first, then comes Balmer. But here what they're given is Balmer is to Lyman. Yeah. Okay. Is that fine? Cool. Yes. Shall we go ahead to the next question coming up on your screen? And here it is. For a hydrogen atom, the ratio of the largest wavelength of Lyman to the Balmer series. Largest wavelength is asked. So think about it. Energy difference is again hc by lambda. So lambda is maximum, so energy difference will be the least. So for Lyman, the transition will be basically from 2 to 1. And for Balmer, it will be immediately ahead. So 3 to 2. That's it. So Balmer series ends at 2, Lyman series ends at 1. So after 1 comes 2. So that's the smallest possible transition or energy difference. For Balmer, it will be 3 to 2. So let's do that. 1 by lambda Lyman will be Rydberg's constant 1 by 1 square minus 1 by 2 square. So this will be 1 minus 1 by 4, which is 3 by 4. So 3r by 4. Similarly, 1 by lambda of Balmer, Rydberg's constant 1 by 2 square minus 1 by 3 square, which is r into 1 by 4 minus 1 by 9. So 9 minus 4 is 5. So 5r by 9 4s are 36. Now divide both of them. That's it. Okay. 1 by lambda of B by 1 by lambda of Lyman. Lambda of B is 5r by 36. This is 3r by 4. So guys, Lyman will go on the top. Balmer will come below. RR has got cancelled. So 5 is there. 36 is below. 3 is below. 4 is on the top. 4 goes with 36 9 times. So 5 divided by 9 3s are 27. So 5 by 27, which is A option. Perfect. A option is the right one. Is that clear? Everyone? Understood? Can we go ahead to the next question? Yeah. So these kind of questions are again very, very common, guys. Let's go. The wavelength of the first member of Lyman is lambda. Wavelength of the next member will be how much? Instead of two different series, Lyman-Balmer pattern, inside the same series, they are asking about two lines. The first member of Lyman will be basically 2:1. It will go from 2 to 1. The wavelength of the second member will be from 3 to 1. That's all. That's the only difference. So let's start doing it. 1 by first member, Rydberg's constant, 1 by 1 square minus 1 by 2 square, which is 1 minus 1 by 4, which is 3 by 4. So 3r by 4. For the second member, it is Rydberg's constant 1 by, what is it? 1 square minus 1 by 3 square, which is r into 1 minus 1 by 9, which is 8 by 9. So 8 by 9 times of r. Okay. So take the division of both of them. So 1 by lambda 1 by 1 by lambda 2 is 3r by 4 by 8r by 9. So lambda 2 goes on the top, lambda 1 comes below, RR goes, so 3 by 4, 8 is below, 9 is on the top. So lambda 2 will be lambda 1 into 9 3s are 27, 8 4s are 32. So 27 by 32 times of the previous one. That is the answer. Yeah. Lambda 2 is lambda 1 into 27 by 32. Is that clear, everyone? Cool. So these kind of variations, we have done all kinds of variations for Lyman, Balmer, Paschen, whatever is possible. These are standard models. Either in the same thing, first line will be asked or last line will be asked. Minimum wavelength, maximum wavelength. These are the maximum type of questions that you can get. Okay. Let's go to the next one on your screen. Here it is. Minimum energy required by hydrogen to emit radiation in Balmer. Lyman, Balmer. 1, 2, 3, like that. 4. If you want to emit radiation in Balmer, where should you go? Think logically. Where should you go? Which energy level should you go? Balmer radiation starts like this. This is your Balmer series. So at least you should be minimum at 3. Minimum at 3. And what is the energy at 3? This is minus 13.6. What is this energy level, guys? What is this particular energy level? Yeah, this is minus 1.5, minus 1.5. This is minus 3.4. Yeah, so at least you should be at this energy level. So don't mark this option. That is wrong. The question is, how much energy will you give? Minimum energy required by hydrogen atom in ground state to emit. Yeah. So what will your answer be? You will have to take it over here. So the difference, that extra energy, will be minus 1.5 minus 13.6. How much will it be, guys? Yeah. How much will it be? 12.1. 12.1 electron volt, which is C option. There you go. That is that extra energy which will be required. So if you give 12.1 electron volt, then it will reach the third shell, then it will emit Balmer series. Very conceptual question. Why difference? Minimum energy required by hydrogen atom in the ground state to emit radiation. I think minimum energy required by hydrogen. How much energy do you require to be given to that hydrogen atom? You require it. I know the statement is not very clear, but it should be. I know you can say that energy at that level is 1.5. That is very debatable. I agree with it. So the framing of the sentence could have been much better. It could have been, how much minimum energy needs to be given to the hydrogen atom so that it emits radiation in the Balmer series. That would be a better framing of the statement. Here it is given how much minimum energy is required. So already hydrogen atom is there. How much energy will it require? It will require 12.1 electron volt of energy so that it reaches here and then it emits Balmer radiation. So you can debate it, but I feel it is understood that it is that extra energy. Got it? Is that clear why? Yes. Yes. So a more appropriate statement would have been the one which I said, how much extra energy is required, but it's okay. We have taken it. What's the longest wavelength associated with Paschen series? What's the longest wavelength associated with Paschen series, guys? Lyman, Balmer, Paschen. So longest wavelength, let's go. Energy is hc by lambda. Longest wavelength means shortest energy difference. So it should be from which number to which number? From 4 to 3. Is that right? 4 to 3. Because Paschen series will end at 3, third level. So immediate next transition is 4 to 3. That's it. So 1 by lambda will be Rydberg's constant. Rydberg's constant is 1.097. They have given 10 to the power 7 multiplied by 1 by 3 square minus 1 by 4 square. That's it. So do the math. 1.097 into 10 to the power 7, 9 and 4. So 16 minus 9 divided by 9 into 16. So this 16 minus 9 is nothing but 7. So that is 1 by lambda. So lambda will be 9 multiplied by 16 divided by 1.097 into 7, and 10 to the power minus 7 will be here. So just do the math and see approximately how much are you getting as the answer. Roughly how much are you getting as the answer? Come on guys, let me know. If you want it 10 to the power minus 6, then yeah, you can do that also. So 10 to the power minus 6, you'll just have to take one extra uh, decimal over here. So 9 multiplied by 1.6 divided by 1.097 into 7 into 10 to the power minus 6, that will also suit. This is roughly 1 only, and 16 and into 9, that's 144. 144 divided by 7 approximately, you can take that. Yeah. So guys, let me know what are you getting. 144 divided by 7. I mean, it's not exactly going to match you, but close enough you can get the answers. 144 divided by 7 will be close enough to 20. Yeah. And so something like close enough to 20 means 18 and 19 and all of that. So I can see B option might most likely match. Yes, B option is the right answer. B option. Perfect. There you go. Yeah, that's perfect. 1.8. Cool, guys. Yeah, awesome. Let's go to the next one coming up on your screen. Identify the hydrogen-like element whose spectral lines are 4 times shorter in wavelength as compared to that of hydrogen. Which element spectral lines look very similar, but their wavelengths are always 4 times shorter? I'll give you an idea. See, if you take any lambda, it actually has the formula RZ square 1 by N1 square minus 1 by N2 square. Is that right? And this is 4 times shorter. That means this is 1/4 of hydrogen. So for hydrogen, Z is nothing but 1. But these values are same, 1 by N1 square minus 1 by N2 square. So notice one thing, this and this will cancel, R and this R will also cancel. So what are you left with? Z square this is lines are 4 times shorter in wavelength as compared to, oh sorry, this was not lambda, this was 1 by lambda. So sorry guys, this was 1 by lambda. So if wavelength is 4 times shorter, that means 1 by lambda will be 4 times more. So this will be 4 into that. So Z square will be 4. So Z will be 2. That means it should be helium. There you go. Yeah, it kind of makes sense. If lambda is 4 times less, that means 1 by lambda is basically instead of taking lambda by 4, so this lambda becoming lambda by 4, so 1 by lambda will become 4 by lambda. So that is why that 4 has been taken on the top over here, because these formulas are for the reciprocal of lambdas. These formulas are for the reciprocal of lambdas. Is that right? Cool. So answer should be helium. Okay, answer should be helium. Perfect, simple. It is just based on the property that 1 by lambda is directly proportional to z square. Yeah, and everybody knows that. Cool. Let's go to the next one on your screen. Which of the following transitions for helium ion will give rise to spectral lines which has same wavelength as the spectral line in hydrogen atom? For helium ion, if you take 1 by lambda in helium is equal to Rydberg's constant Z is 2, so 2 square, 1 by n1 square minus 1 by n2 square. Similarly, if I take for hydrogen atom, 1 by lambda hydrogen will be R, 1 by whatever. Which of the following transitions of helium ion will give rise to spectral line which has same wavelengths? So this will be, let's say, n3 square minus n4 square. Now, if you compare the two, what you are getting is, because they should be the same, 4 multiplied by this number 1 by n1 square minus 1 by n2 square is equal to 1 by n3 square minus 1 by n4 square. Now take that 4 inside, you will see it will become 1 by 2 square. Sorry, this is 2 square. So 2, if I take it below, it will become n1 by 2 whole square minus n2 by 2 whole square is going to be 1 by n3 square minus n4 square. Just check this out. Just equating their wavelengths. This 2 square is 4. If I take it inside, it will become 2 square. 2 square, I can put it below also. Nothing wrong. So from this, what am I getting? n1 by 2 is basically n3 and n2 by 2 is basically n4. This is n3 and this is basically n4. So basically, in hydrogen, if n3 is 1, then this can't be 1 by 2. So at least this should be like 2. Uh, or let's say if this is 1, then this will be basically n1 will be 2. And if this is 3, then this will be 6. If this is 2, this will be 4, and so on and so forth. Are you getting my point? So basically they are kind of double of each other, you can say. So is it possible that you have 4 to 2? Just check it out. 4 to 2, is it possible? 6 to 5, is it possible? 6 to 3, is it possible? What do you think? Odd numbers are definitely not possible, because you can see this number has to be divisible by 2, and this number is also going to be you can say sorry, this number also has to be divisible by 2, so this number also has to be even number, so they have to be definitely even. So from this, n1 and n2 are definitely even numbers. That is one thing which we can understand. So if they are even, this is not possible, even this is not possible. 4 and 2 are even numbers, so A option is the right answer. That was the idea behind this particular question. So we compared the wavelengths, we restructured the problem, we saw it is nothing but an odd even kind of a question. So if this is divisible by 2 to give an integer, n1 and n2 must be even numbers. So the transition in that helium should be between even numbers, so that you get same wavelengths as in hydrogen. Got it? How many of you understood this concept, guys? Let me know quickly in the chat box. Very good, very good, very good. Excellent. All right. Next question coming up on your screen. A photon collides with an atom at rest inelastically, then just after the collision, which is not true. Inelastically. Inelastically means what? This is the nucleus, these are the orbits of that atom, and then you have this photon which is colliding. Inelastically means it should be absorbed. So what will happen if there was an electron over here inside that atom? This was the nucleus. That electron will jump to higher energy level. It has got excited. It has got excited and the photon has been absorbed. And because the photon will have some momentum, this atom will also begin to move, and there will be some motion in that atom. Or am I visible, audible? Let me know quickly in the chat box. Yes, let me know guys quickly. Audible, visible. Okay, perfect. Yes, I should be. Yes, okay. So we'll complete nucleus and then we'll take a break. Okay. All right. Perfect. Perfect. Let's begin. First question from nucleus. Here it comes. The nucleus is splitting, disintegrating into two smaller nuclei with mass in the ratio 2:1. They will move with what speeds? In same direction, opposite direction? What do you think? So if you have a nucleus and it splits into two smaller nuclei in the ratio of 1:2, so this is m, this is 2m, original mass 3m was basically at rest. To conserve the momentum, this will have 2v speed, this will have v speed. So basically they are conserving the total momentum. Conserving the total momentum. This has a momentum of m into 2v, that has a momentum of 2m into v, but direction wise they are opposite, so they will cancel out. They will give a total momentum of 0, which was the original momentum. So the original momentum would have been 0. Final momentum will be 2m into v minus m into 2v, which is absolutely correct. So velocities are definitely in the ratio of 1:2, but they are going in the opposite directions, 1:2. Is that clear, everyone? First option, option A. Let me know if you guys were able to get this question. Were you able to see this question, hear this solution? Shall we go ahead then? Okay, perfect. Shall we go ahead? Okay, cool. So next question on your screen, here it is. The mass number of a nucleus having radius equal to half the radius of the nucleus with mass number 192 is how much? The mass number of the nucleus having radius equal to, so this radius R1 equal to half the radius of the other nucleus. Now, okay, R2's mass number is known. This guy's mass number is how much? We know one thing, that atomic mass number and radius are related to each other. Yeah. And atomic mass number is essentially directly proportional to, what do you say? Atomic mass number is, no, radius is proportional to cube root of atomic mass number. That was the relationship, if you're remembering it. R is equal to R naught into A raised to 1 by 3. That was the relationship between the radius of a nucleus and atomic mass number. So that is the scenario. I can say R1 will be some constant into A1 raised to 1 by 3. R2 will be some constant into A2 raised to 1 by 3, whole thing divided by 2. Constant will go off, and therefore A1 will be raised to 1 by 3 will be A2 raised to 1 by 3 divided by 2. So A1 will be A2 divided by 2 cube. Now A2 is already known, which is 192 divided by basically 8. So we'll get the value of A1, 192 divided by 8, guys. Check it out. I think it should be 24. Yes, check out. 24. Yes, that is absolutely the right answer. So I'm just using this concept. From this, we can see R is constant into A raised to 1 by 3. In general, this is a golden formula for nucleus. Correct? So option B is the correct one. Next one on your screen. Which of the following is not true regarding nuclear forces? They are independent of charge and mass. They don't follow inverse square law. They depend on the spin. They can act only between protons and neutrons. Which of the following is not true? They have asked. Which of the following is not true? They are independent of charge and mass. Yes. In fact, they depend on the spin and very short range. They are the shortest range forces. They do not follow inverse square law, meaning like force is 1 by r square kind of formula is not there. They can act between proton proton, neutron neutron, and even proton neutron. So this is the part which is wrong. They can act only is wrong. They can also act between proton proton, proton neutron, anything. So D is the incorrect option. D is the incorrect option. Is that clear, everyone? Shall we go ahead? Next one. Assertion reason kind of question. Let's see if we can figure this out. The binding energy per nucleon is found to be practically independent of the atomic number A for nucleus whose mass numbers are between 30 and 170. Nuclear force is long range. In the light of the above statements, choose the correct answer. What do you think? See, the binding energy per nucleon, if you see the graph, and that graph goes something like this. And for a decent range over here between 30 and 170, you can see almost it is same. It has not changed much because after that it can drop, but almost it is the same for majority of the elements, which is definitely making the assertion correct. It is practically independent of the atomic mass number. The nuclear force is long range. Is that the right answer? I mean, come on, guys. How come nuclear force will long range? It is in fact short range. So this is wrong. So assertion is true, reasoning is false. So A option. Nuclear force is in fact the shortest range, femtometers. Yes, perfect. Clear? Let's go to the next question on your screen. What is the energy which is there in 1 gram of a substance? 1 gram of a substance. So you have to basically use, if you destroy 1 gram mass, the energy related is mc square. Mass is 10 to the power minus 3 kilos. C is 3 into 10 to the power 8 value. But whatever you get will be in joules. Notice answers are in mega electron volt. So need to be little bit careful. So what we'll do? We'll take this 10 to the power minus 3. 3 square is 9. This will become 16. If you want to make it in electron volt, divide it by 1.6 into 10 to the power negative 19. This will be in electron volt. Got it, guys? This will be in electron volt. Yeah, you have to divide this with the value of E. Lot of students forget whether you have to divide or multiply. Whenever you have to convert it into electron volt, divide. It is in electron volt, you have to make it into joules, substitute the value of E. That's all. That's the best way of looking at it. Now 9 by 16, okay, we'll just keep it as it is, 9 by 1.6, or we can also write it as 90 by 16, one and the same thing, into minus 3 and 16 will make it minus 13. Minus 13 and minus 19 will make it plus 6 electron volt. So this is basically mega electron volt. And 90 by 16, guys, 16 5s are 80. So I think it will be 5.6 mega electron volt. But do I have 5.6? Oh, sorry. This is not 10 to the power 6. This will become 10 to the power 13 and this will be 19, my bad. And this will be 10 to the power basically 32. 10 to the power 32 would be there. So now what we can do, 5.6 into 10 to the power 6 into, so if I write 10 to the power 6 separately in electron volt, I'll be left out with 10 to the power 26 over here. So this will become 5.6 into 10 to the power 26. This is mega, so this is mega electron volt. So I think option A will be the right answer. Yep, absolutely right. There you go. So I had to convert it into mega electron volt. That was the only tricky part. But other than that, mc square, it is in joules. So you convert it into electron volt and just have to adjust the power so that it looks like mega electron volt. That's all. Yep. Okay. Yes, Arivasu, only for problem solving and build that habit. And you have to see all kinds of questions because I don't want you to think in the exam how to solve this. You should have already done it and you should know, okay, I've done this. Okay, I start. Already you should, your hand should start moving. That was the whole purpose of this conduct that problem solving. Okay, let's go ahead to the next question on your screen. Binding energy of a certain nucleus is this many joules. How much is the difference between total mass of the nucleons and the nuclear mass in this situation? It's the reverse problem. Energy is given, mass is asked. Best part, they have already given the answer in joules. So if you directly use E is equal to mc square, energy is 18 multiplied by 10 to the power 8. This is mass difference basically, mass defect. And C is 3 into 10 to the power 8 and this is whole square. So delta M will be 18 into 10 to the power 8. 3 square is 9 and this will be 10 to the power 16. 18 by 9 is 2 and this will become 10 to the power minus 8. So whatever answer I got is in kg. This is in grams. We need to be little bit careful. Kilo is 10 to the power 3. So 2 into 10 to the power 3 into 10 to the power minus 8 grams. And this will become 2 into 10 to the power minus 5 grams. Now I can write it as 20 into 10 to the power minus 6 grams. So technically this will be 20 micrograms. SI unit is not grams, it is kg. So small silly mistake can happen over here, which can give you a completely different answer. So this was whatever answer I get will be always in kg SI system. So I converted kg into grams. So I got 10 to the power minus 5 into 2 grams. I will write 20 into 10 to the power negative 6. So that negative 6 power will become micro. And then the answer should be option A, I believe. Yes, perfect. That makes sense. It was a very nice question. How many of you loved this? Especially play with the units. Otherwise, there is nothing great about this. But this gram and that kilogram will create that confusion. Is that cool? Everyone? Beautiful question. Let's go to the next one coming up on your screen. M naught is the mass of this isotope. MP and Mn are the masses of protons and neutrons. The binding energy is how much? Mass defect. I will need, only then I can get the binding energy. So binding energy is mass defect into C square. Mass defect is nothing but the total mass of protons and neutrons minus the mass of nucleus, mass of the nucleus, whole thing into C square. Now, how many protons are there? 5 protons. So 5 times mass of the proton. How many neutrons are there? 12 minus 5, which is 7. So 7 times mass of the neutron minus mass of that nucleus, which I say is m naught into C square. So 5 mp plus 7 mn minus m naught into C square, which is option A is the right answer. Option A. I hope this is absolutely clear. How negative 6 for the previous question? This was 2 into 10 to the power minus 5. I want to make it negative 6. So what will I do? I'll multiply by 0 so that powers are balanced. So this is 2 into 10 to the power minus 5. I'll write 1 0 extra. So I need to put one extra decimal. So one more extra negative power. So then that will become 9. Is that okay? Is that okay, Rishabh? Yep. Clear how we did it. Shall we go ahead now? Yeah. Next one on your screen. Here it is. Energy released when two deuterons fuse to form a helium nucleus is how much? Binding energy per nucleon is this much, and binding energy per nucleon of helium is this much. How much is the energy released per when the two deuterons fuse together? This is a very good question where binding energy and the energy Q value calculations are asked. And whenever such questions come, remember one thing: the Q value, which is that energy which is released in any kind of nuclear reaction, not chemical, nuclear reaction, is nothing but whatever is the binding energy of that product minus whatever is the binding energy of those reactants. Now, in this particular situation, what has happened is two deuterons, so H21, combine together to give He4. Now, this is your product, this is your reactant. As simple as that. So, if you understand this much, getting this part will be not difficult. How much is the binding energy of, let's start with the product. The product. It will be the binding energy of helium. It will be nothing but how many ever nucleons are there in helium multiplied by binding energy per nucleon for helium. A anyways get cancelled. So it is atomic mass number into binding energy per nucleon. Now binding energy per nucleon for helium is given to be 7, and there are 4 nuclear particles in helium. So 4 into 7, which is 28 mega electron volt. That is for the product side. So this particular number I got to know is 28 minus something will come. We'll figure that out. Next is how much is the binding energy of the reactant, which is nothing but binding energy of hydrogen. But remember, there are two reactants, two hydrogens, so 2 times of that. Do you understand why this 2 has come? Because of this 2. 2 hydrogens, so each hydrogen will have a binding energy. So you take that 2 times because 2 of them are there. So that will be atomic mass number of hydrogen into binding energy per nucleon of hydrogen. Atomic mass number of hydrogen is 2. Binding energy per nucleon is 1.1. So it will be 4.4 mega electron volt. So put 4.4 over here. What are you going to get, guys? Yeah, come on. What are you going to get? Yes, 23.6 mega electron volt, which is option C, I believe. Yes, that is the right answer, of course. Okay, so remember, it is always product minus reactant. Binding energy is binding energy per nucleon into the number of nucleons. So you multiplied it with the atomic mass number on the top. Here there were 2 reactants, so that's why I have to put 2 of them. That's all. As simple as that. Okay. Which part you did not understand? Please let me know. Damadam. Yeah. Now, if you do not know this formula, then you will have to go back to nuclear physics. Okay. Simple. So this is standard formula which is there in nuclear physics for any kind of nuclear reaction. The product side and the reactant sides will have their own binding energies, but any nuclear reaction will always involve some energy loss or energy gain. That is called as the Q value of that reaction, and that energy gain or loss is just given by this formula. Binding energy is nothing but mass defect into C square, which is also nothing but binding energy per nucleon into the number of nucleons. Okay, direct. Yeah. Okay. Cool. Perfecto. Perfecto. All right. Oh, don't worry. I'll kick them out. Thank you for pointing it out, Harivasu. Don't worry. Yeah, I don't want anybody randomly coming over here and spreading some random nonsense because we are all uh, focusing on the lecture. Okay. All right, Damadam, I think that is clear. So let's go to another question coming up on your screen, and here it is. Wow, this is also a good level question, guys. Energy released in fusion of 2 kg of hydrogen is EH, and energy released in fission of 2 kg of uranium is U. EH by EU is approximately how much? Considering for fusion you get 26.7 mega electron volt per reaction, and for fusion you get 200 mega electron volt per fission. Very nice question, guys. This is not so I mean, it's simple, but do not take it very lightly because chances of making such silly mistakes are definitely going to be there. Let's start. If you have 2 kg of hydrogen, how many reactions will happen for what is it? Fusion. So if I'm talking about fusion reactions, check it out. For one fusion reaction, you need 4 hydrogen atoms. And each hydrogen atom weighs how much? Each hydrogen atom will weigh how much, guys? Each hydrogen atom will weigh how much? 1 gram of hydrogen, right? So it is going to weigh 1 gram. So one fusion has 4 grams of hydrogen. You can, or you can say that, one hydrogen atom is corresponding to 4 grams roughly. Okay. So think about it. Think about it. If you consider all of these in moles, you are getting 26.1 mega electron volt if you have exactly 4 hydrogen atoms. So now think how many hydrogen atoms, okay, or rather how many hydrogen, I would say how many fusion reactions with 2 kg hydrogen you will get. How many fusion reactions you will get with 2 kg of hydrogen atoms? Now 2 kg means 2000 grams. If you divide it with 4 hydrogen atoms weight, which is nothing but 4 grams, divided by Avogadro's number, which is 6 into 10 to the power 23, you get the mass of 4 hydrogen atoms. Is that right? These many reactions will occur. These many reactions will occur with 2 kg of hydrogen. How many of you got this concept? First of all, tell me. 2000 grams of hydrogen is there with us. So in one reaction, we have 4 hydrogen atoms. 4 hydrogen atoms means how much mass? 4 grams. Yeah, divided with your Avogadro's number, you get that much as your answer. Is that simple, straightforward with all of you? Yeah. Now, fusion reactions which occurred are this much. So how much energy will be liberated with the hydrogen? The answer will be 2000 divided by 4 divided by 6 into 10 to the power 23. Each reaction gave 26.7 mega electron volt. So you multiply that with 26.7 mega electron volt. That much energy will be there with 2 kg of hydrogen undergoing fusion reaction. That is the logic behind it. Similar logic, you use it for, what is it? Uranium. Similar logic, you are going to use it for uranium. So one fission which is happening, every fission that is happening involves exactly one uranium atom. There is a difference here. Exactly one uranium atom is involved in one fission reaction. So the number of fissions with 2 kg of uranium, how much will it be? 2 kg means 2000 grams upon mass of every uranium atom. So it will be nothing but 235 divided by Avogadro's number, 6 into 10 to the power 23. That much grams. That much gram. So, next part, what will be the value of EU? The value of EU will be whatever you got over here, 2000 divided by 235 divided by 6 into 10 to the power 23. Per reaction, you got how much energy? 200 mega electron volt. So with these many reactions, you will get into 200 mega electron volt of energy. Is this concept clear? Now, last part. Okay, we got EH and we got EU also. We got EH and we have got EU. You just have to divide both of them. You just have to divide both of them. EH divided by EU. A lot of things will get cancelled. Like Avogadro's number and 2000 will get cancelled. EH will have 4 below. EH will have 4 below and 26.7 on the top. EU will have how much? 200 over here and 236 below. Solve this and see what is the answer that you are getting. That will be your ratio. What a brilliant question. Yeah, definitely, Pritija. Why not? What is the answer, guys? Come on. 4 goes with 26 point something. 4 sevens are 28. This is almost going to be 6 point something. This is almost going to be 1 point something. So it will be close enough to 7 point something, I believe. So 7.62 should be the answer. Don't sit and calculate it. There is only one option like that. Don't break your head. Don't sit and calculate it. Yeah, I hope you loved this question. It is brilliant, of course. No doubt about it. Okay. Yeah, that is the answer. Good question, great question, very nice. So basically, mole concept is there in a way. Yeah, how many of you realize this is actually a physical chemistry question, mole concept kind of question, nothing more. All right, moving on, next one on your screen. Unfortunately, I'm not sure whether this is very clear or not. So I'll just turn off the lights, match the following, guys. I hope it is visible clearly. There is a uranium reaction which is giving Xe, Sr and neutrons, 2 hydrogens and oxygen giving H2O, hydrogen and hydrogen giving helium and neutron, 2 hydrogens giving deuterium hydrogens. Okay, so that is the kind of equations given on the left hand side. Chemical reaction, fusion with positive Q value, fission and fusion with negative Q value. Okay, that is the thing. Now, one thing is clear. Water formation is basically chemical reaction, nothing great about it. Fission is where uranium is bombarded with neutron and it disintegrates into daughter nuclei. Now, among these two, guys, hydrogen and hydrogen forming helium happens in the sun and lot of energy is liberated. So this has to be positive Q value. Naturally, this will be fusion but with negative Q value. That's the logic behind it. So I think B option will be the right one. Yes, that is correct. So sun, nuclear fusion happens in the sun and a lot of energy gets liberated. That is this reaction, hydrogen giving helium and neutron. So positive value. Negative Q value means you need that energy inside that reaction. So it absorbs that energy. So that was the D reaction. Very straightforward. But I'm guessing it was not visible for some reason. No issues. Maybe in the PDF it will be seen. So next question. Choose the correct nuclear process. Neutron, proton, E plus is positron. It's like the brother of electron with the same mass, same charge, but of opposite sign. Nu is neutrino, nu bar is antineutrino. These are all subatomic particles. Yeah, this is a very common reaction. Neutron disintegrating into proton and electron with a what? Antineutrino. B option, correct. This is the correct answer. And the opposite reaction is, if you take electron on the other side, what happens is, see, neutron giving proton, right? If you take electron on the other side, it will become minus E minus. Minus E minus is basically E plus, plus neutron is coming from the proton now. And that neutrino which is there, that also if you take on the other side, antineutrino, sorry, then on the other side it will become neutrino. So this is the opposite reaction which happens. Proton going into neutron plus positron with a neutrino. This is the exact opposite of that. Electron going on the other side becomes positron, antineutrino becomes neutrino. Okay. One is a beta plus decay, one is a beta minus decay. In this fission reaction, can you figure out what is that emitted particle? What is that emitted particle? Okay. Always remember, for such things, the subscript and the superscript both should match on the LHS and RHS. So LHS it is 236, RHS it is 141 plus 92 plus 3 times of something. And below it is 92 is equal to 56 plus 36 plus 3 times of something. What are those things? Quickly figure it out. What are those things? Quickly figure it out. This is your atomic mass number. See what it is coming out to be. And this is your Z number. See what is it coming out to be. Come on, guys. Tell me the answer in the chat box quickly. Yeah. What is it? 56, 36. That's exactly 92. So Z will be 0. What is A going to be? 92 and 141. That's going to be 133. So this will be divided by 3. So it will be 1. Oh, 1, 0. This comes only for neutron. So it should be a neutron, guys. That's the correct answer. Very good. Neutron. So that's how you figure out any unknown particle, by balancing the subscripts and the superscripts. Okay, LHS and RHS should match. Next one, which of the following fragments corresponding to the nuclear fission between neutron and uranium isotope is correct? This is a standard nuclear reaction which is given in your NCERT. If you know it, or else you don't know it. What are those 3 products? In fact, it was there in one of the previous slides in the match the following also. So if you have not match the following and something else, it would have been there. So if you have U-235 nuclear fragments, then what are those 3 elements you get? Yes, barium, krypton, and neutrons. Yeah. Now, the difference between them is 4 versus 3. You always get 3 neutrons, not 4 neutrons. Otherwise, both the elements are same here. Be careful, this is 4 versus 3. It's always 3 neutrons which are going to come out. Yeah, option D. Correct. Very nice. Many of you got it. Next one. An element 129x60 decays into 121y59. The number of alpha and beta particles are. Now, what you should do for such things? What is the original atomic mass number? 129. Final atomic mass number? 121. Take the difference. This is atomic mass number I'm talking about. The difference is basically 8. And we know every alpha particle reduces the mass number by 4. So if it has to be 8, it has to be basically 2 alpha particles, because every alpha particle reduces it by 4. So alpha particles is 2, number 1. With that, also Z reduces. So 60 will become minus 2. Sorry, every alpha particle will reduce the atomic number by 2. So if there were 2 alpha particles, so 2 alpha particles are there. So they will reduce it by 4 because every alpha particle is going to reduce the atomic number by 2. So 60 minus 4 is going to be how much? 56. This is only because of the alpha particles. But the final atomic number is 59. Final atomic number is 59. How can this happen? Plus 3 will come from beta particles. Beta particles increase the atomic number by 1 unit. Hence, there should be 3 beta particles, which is option A. So whenever you get such questions, always start with alpha particles atomic mass number. That will result in the reduction in the atomic number. Then compare that with the final atomic number. From that, you can figure out how many beta particles are going to be emitted. Next, although this can be treated like a question of law of radioactivity, but still it can come, and you cannot really argue that this I cannot do and all of that. So the material radioactive P first decays into Q, then finally it decays into R. So if you see how much P, Q and R will be there, what do you think will be the correct answer? Initially, I feel P will be maximum, this will be 0, this will be 0. Eventually, everything will convert into R and nothing of Q and P will be remaining. Nothing of Q and P will be remaining. So Q and P should be 0. Eventually, this is not correct. P and Q are 0. R will be maximum. Okay, this seems correct. What about this? Q is becoming maximum? No. Q is becoming maximum? No. There is only one option like that, which is 2. Therefore, this should be the correct answer. Yeah. Also, what happens is intermediate at one point of time, this reduces, this increases, this is also increasing. In some instant, you will see the product Q will be reaching a maximum value before it again starts decaying into R. So that's why you will see Q increases, but when Q increases, more reactions of Q to R will happen and eventually it will reduce back to 0. So there is a brief moment when it reaches a large value and before it finally becomes 0. So hence option 2 is the right answer. Now it's time for break. What's the time? It's 7:40 and we will resume at around 8:10 or something. Half an hour break we'll take and then we'll continue with semiconductors and logic devices. Okay, it will take I think 1.5 hour, not more than that. And yeah, that will be the last part of the session. Cool. So everybody, see you at 8:10 or 8:15. We'll meet soon. Okay. See you. Hello, welcome back. Let me know quickly if I'm audible and visible. Yes, call all your friends. The final leg of the marathon session is about to start. Yes, guys. We started off with photons, photoelectric effect. We went on to wave particle duality, atomic structure, nucleus, also done with radioactivity. And now it's time for semiconductors and logic gates. Yeah, ready for it, guys? Semiconductors starting now. Perfectly audible. Yes, perfect. Mohana. Yes, Harni, welcome back. Captain Ibu, perfectly. Yes, Karthik, good evening, good evening, good evening, everyone. Okay, looks like thing is visible. Okay, great. Let's begin then. Let's begin with the class. And here, oh, sorry, I showed the answer, but anyways, the energy gap between valence band and the conduction band for a material is 6 electron volt. The material is. So, your conduction band is here and your valence band is over here, and this gap, if it is more than 1 electron, 1.1 electron volt, then it is too difficult for an electron to jump over here and conduct electricity. So this energy gap means it is going to be difficult for conduction, so it is going to be an insulator. If it is a metal, they will overlap. If it is like 0.1, 0.3, 0.7 electron volt, then it is a semiconductor. Okay, so that is the answer for it. I hope this is clear. Let's go to the next question coming up on your screen. Okay, get ready. The conductivity of a semiconductor increases with increase in temperature because what happens? It's the same logic actually. You have your conduction band and you have your valence band. So normally a couple of electrons are there in the conduction band. But this valence band can contribute to more energy, more electrons if this gets excited, these electrons get excited. So you need extra thermal energy so that they enter the conduction band and these electrons begin to conduct even more. So what happens in this case? Yep, the current carriers increases, relaxation time decreases, but effect of decrease in relaxation time is much less than the increase in the number density. Yeah, that is the reason for it. D answer, meaning B option which says B. So this kind of options are very bad, where A says C, B is saying D. The answer is D statement, but the option is B. So what it says over here is the number of charge carriers. That means more electrons are coming into play. But with that comes another problem. When it becomes crowded, so they will collide more frequently with each other. That will actually reduce the conductivity. But that effect is much less. I mean, it is hardly adding to the crowd. It's not too much of crowd. So it's okay. That effect is compensated much higher than with the number density. But with conductors, what happens? If you might think that if I heat it, more electrons will conduct and it will be better in conduction. Problem is, already it has so many electrons freely available. Adding more electrons is not going to cause increase in conductivity. Rather, it will cause more crowding, which reduces the relaxation time. So that is why with the temperature, conductivity reduces for conductors, but for insulators, sorry, semiconductors, it actually increases the conductivity and resistance reduces. Okay, it's exactly opposite. Okay, sir, need live for other topics too? Yes. Okay, we'll do as many units as possible. Next unit which we are going to do is mechanics, man. Okay, Ashwant, we're going to do mechanics. Let's go to the next one. In intrinsic semiconductors at room temperature, the number of electrons and holes are number of electrons and holes at room temperature in intrinsic. Intrinsic means pure. There is no doping, there is no extra P, there is no extra N. So number of holes and electrons are obviously going to be equal. It's not going to be zero. It's not going to be infinity. It can't be unequal. Unequal happens in extrinsic semiconductor where holes or electrons are more depending on N or P type. And equal means intrinsic semiconductors, right? Perfecto. Yes. D option equal. I think everybody got it. Very nice. Let's move to the next question on your screen. Here it comes. For extrinsic semiconductors, meaning p-type or n-type, where you dope it with a pentavalent or a trivalent impurity, when doping level is increased, Fermi level for p and n-type semiconductors will go up for T more than T naught Kelvin, and downward for T less than T naught Kelvin, and TF is the, or T naught is basically the Fermi temperature. Fermi level of p-type semiconductor will go upward, Fermi level of n-type will go downward, Fermi level of p and n-type will not be affected. Hello, am I audible? Yeah, is it better now? Just check it out. And were you able to listen into this particular explanation? Let me know quickly in the chat box. Was this explanation audible to all of you? Yeah, so here I said in n-type, the Fermi level increased. In p-type, the Fermi level decreased. Because instead of jumping from here, now you're just jumping from here. Or in p-type, instead of jumping to here, you're jumping to a lesser height. So that is the reason for the D option to be right. So Fermi level of p-type semiconductor will go down. So for p-type, instead of going to this level, you are jumping now to a lower level. Okay, because p-type has holes which are created by the trivalent impurity. N-type has pentavalent impurity with added electrons, which makes a new energy level here. So now instead of jumping from here to here, you are jumping only from here to here. So the Fermi level has increased. So for N-type it increases, for P-type it reduces. I'm just reiterating the same thing whichever I told. Okay, perfect. That is the reason for it. All right. This I have taught you in our semiconductor class. In case you have missed it, please watch it. Okay. Carbon, silicon, germanium have 4 valence electrons, correct? At room temperature, which of the following is most appropriate? Okay, interesting. The number of free electrons for conduction is significant only in silicon and germanium, but small in carbon. It's significant in carbon, but small in this. Number of electrons is negligible, small in all three. Number of free electrons is conduction is significant in all the three. And this is actually a doubt which many kids ask. In the group 4 elements, yeah, we have carbon, we have silicon, we have germanium. But why is it that while making semiconductors, we never take carbon? We only take silicon and germanium. The answer is actually this, question. The free electrons are only significant only in silicon and germanium, but in carbon atoms, those electrons are barely there in the conduction band, which does not qualify to become a semiconductor that well. So if you cannot conduct electricity anyhow, so I mean, you will just say that, okay, you better not be a semiconductor, you be an insulator. So carbon more of an insulator than a semiconductor, whereas silicon and germanium, even though it is in the same group of the periodic table, it has more electrons which are in the conduction band. Is that clear, guys? Yeah, option A is the right answer. This is one common doubt which many kids actually have. Okay. This next question. Consider a N type of semiconductor in which any NH are the number of electrons and holes standard. Holes are minority, dopant is pentavalent, any NH is not Ni square, any NH is more than Ni square. Holes are not generated due to the donors. Choose the correct answer from the options given below. Okay, let's see. First of all, N type of semiconductors means number of electrons are much larger than the number of holes. So holes are minority, so which is absolutely correct. Holes are minority. The dopant is pentavalent, that is why electrons are coming into play. So A is correct, B is also correct. These two statements are definitely wrong. In fact, always Ne into number of holes is always going to be Ni into Ni, which is Ni square. This is always true. You cannot say it is not equal to or more than, that is wrong. Holes are not generated due to the donors. Holes are not generated due to the donors. Holes are generated because of thermal. Correct. They are formed due to the thermal collisions between the atoms. So they are not generated due to donors. Correct. In fact, they are generated due to thermal collisions. Due to thermal collisions you are going to get electron hole pairs. Electron holes pair you get. The electrons are coming because of the donors. The pentavalent atom had 5 electrons in the valence shell, so that fifth electron is acting like that donor and creating that electron which is available for conduction. In a p-type semiconductor, which is trivalent, the vacancy of electron is due to the acceptor atom, and that creates that extra holes apart from the regular electron holes which are formed due to thermal collisions. So A, B and E, I believe. A, B and E, which is option A. Which is option A. Correct. Very nice. Couple of you got it. Very good, guys. Moving on to the next question. Pure silicon has electrons and holes of this much concentration. If hole is increased to this much, what is the electron concentration? Direct formula, Ne into NH is intrinsic concentration square. Electron concentration I do not know. The whole concentration is given to be 3 multiplied by 10 to the power 22. Intrinsic, which is before adding anything, electrons and holes will be equal. So this would be the intrinsic concentration. So Ne will be 1.5 square is 225. So 2.25 into 10 to the power 32 divided by 3 multiplied by 10 to the power 22. So this will become 10 to the power 10. So you will have 2.25 divided by 3, which is almost like 0.7 or something. So 0.7 into 10 to the power 10, or you can say 7.5 into 10 to the power 9. This is 3 by 4 actually, close enough to that. So you can say this is option number D. So this will be 7, this will be 0.75 almost into 10 to the power 10, which is as good as saying 7.5 into 10 to the power 9 only. So D option is the most appropriate answer. Yeah, very simple. Ne into NH is Ni square. Yeah. There are 145. See, some of the models are repeated, and whatever I am taking today is not necessarily from 2019 to 2024 or 2021 or 2025. These are in general the trends which I have seen. Forget 2019. Even before that, whatever I am seeing are most important models of questions which every kid must know. And sometimes some questions are very unique, which might not be even asked before. So those models also I am taking, because maybe it has not been asked before. So it might be asked this time. And every year there is always a new model which is created in the JEE Mains. So all sorts of questions, whatever are possible, I'm trying to do from modern physics. Maximum models, I would say. Okay? Right. Moving on to the next question on your screen, and here it is. In pure crystal or silicon, there are these many electron hole concentration. Now 20 to the power 21 phosphorus atoms are added. What is the new hole concentration? I'll tell you what, this is exactly similar to the previous question. This is basically Ni, and if you add phosphorus, it means it is going to be N type of semiconductor. It is pentavalent impurity. So again, Ne into NH is Ni square. Electrons are now 10 to the power 21. Whole concentration I do not know. Ni is 10 to the power 16, but square of it. So NH will be 10 to the power 32 by 10 to the power 21, which will make it 10 to the power 11. So that is option B of both holes and electrons. So E is basically 1.6 into 10 to the power minus 19. Electron electron mobility is given as 4. Electron concentration is given as 5 into 10 to the power 21. But the funny part is mu hole, which is hole mobility, is 0.5 into 10 to the power minus 5. I know NH is not given, but even if it was given, this value is very less. So this value being very small, it is going to be neglected. It is going to be neglected Even if it is 10 to the power 21, 22, 23 also, this is negative 5, guys. So big number plus a small number is that big number. So might as well approximately say this is 1.6 10 to the power negative 19 multiplied by 4 into 5 into 10 to the power 21. That's it. 4 5s are 20. Is that right? 20 into 1.6, that's 16 into 2, which is 32, into 10 to the power 2, which is 3200. For conductivity, it is ohm inverse, meter inverse. So 3200 is option A. That's it. That's the answer. Very simple. So most of the times you will see this part gets neglected. Not just this question, many questions. Usually this is never even considered because whole mobility is always going to be less. Okay, cool. Let's go ahead to the next question on your screen. Mobility, again, this kind of question is defined as the ratio of the drift velocity and electric field. Okay, for an n-type, density of electrons is given, their mobility is also given, resistivity is asked. Since it's an n-type semiconductor, contribution of holes is ignored. So just like before, holes, I'm ignoring it. So conductivity, although it is conductivity of electrons plus conductivity of holes, it is neglected. So it is just conductivity of electrons, and conductivity of electrons is electron charge, uh, electron concentration into mobility of electrons. This is conductivity. So resistivity, which is 1 by conductivity, will be 1 by E, Ne and mu E. So you just have to now substitute the values. Resistivity is 1 divided by conductivity. So 1 divided by 1.6 into 10 to the power minus 19. Concentration of electrons is 10 to the power plus 19 and mobility is 1.6 SI units. So minus 19 cancels. So it will become 1 by 1.6 into 1.6, which is basically 256. So 2.56, which is roughly 0.4 ohm meter, which is basically option number C for Captain Shreyas. Got it? Yeah, everyone? Is that clear? So today there is a YouTube crash out from 4 p.m. Just came to know from Google developer side. Oh, is it? Oh my God. Then it will be a problem for everyone everywhere. And it had to happen during this marathon only. God knows how many people would have left the stream because I saw attendance was good initially and suddenly it has dropped drastically after the buffering. So maybe as a recorded class, everybody will enjoy it. Okay, and I will trim those parts wherever there were breaks and cuts so that it looks like a good, concise lecture for everyone. Okay, we'll do that if possible. All right, so that was the answer. Moving on to the next question. This is very similar, guys. I'm pretty sure you will be able to do it now. Same thing. For electrons, concentration is this much, hole concentration is there, but mobility is much higher for electrons as compared to holes. Find the conductivity. Will you be able to do it now? It's a very similar question. It's a very similar question to this one, where two things were there, but one thing was neglected in front of the other, and we got the answer. Same logic you have to apply over here also. Yeah, will you be able to do it? Okay, perfect. Kudos. Great, great, great. Amazing, amazing. All right, cool. Let's go to another question coming up on your screen. Here it is. In a semiconductor which is made by doping silicon with phosphorus, a second semiconductor is made by doping silicon with aluminum. The two are joined to form a PN junction and connected to a battery such that Y is joined to negative, X is joined to positive. Which of the following is correct? Yeah, very interesting. Potential barrier is raised or lowered, current is due to minority. So X is connected to phosphorus, that means X is N type of semiconductor. Y, on the other hand, is connected to aluminum, is doped with aluminum. It is a trivalent impurity, so it is P type semiconductor. Now, Y is connected, P is connected to negative. So P is connected to negative. So X is connected to the positive. So N is connected to positive. It means In your PN junction diode, if this is P, this is N is connected to positive terminal, P is connected to negative terminal. This is going to be reverse bias of the diode. If it is a reverse bias, potential barrier is going to be raised and the current is due to minority charge carriers. C option. Yeah. It is not going to be due to majority carriers. Minority people will be carrying it. That is why the current is very less. It is also referred to as the leakage current. Yeah, mainly the drift current which is going to come, and drift current is always due to minority carriers. Diffusion is due to majority carriers. You can roughly say that. Okay, so hence that is the answer. Next question on your screen. Statement 1 says by doping silicon semiconductor with pentavalent, the electron density increases. Absolutely correct, because pentavalent has extra electrons, so it will make it N type of semiconductor, so electrons density will increase. N type semiconductor has net negative charge. This is wrong, it has net zero charge. So this is wrong, this is correct. 1 is true, but 2 is false. Even a p-type semiconductor, guys, has a no net charge, positive charge. Many people think, sir, extra electrons are there, so negative charge, no. Don't forget, the pentavalent impurity, whatever, let's say phosphorus, yes, it gave one extra electron, but do not forget there is one extra proton in its nucleus, so it neutralizes. So even in aluminium, you might say, sir, there is one less electron, so net charge is positive. Do not forget, aluminium will have one less proton in its nucleus. So that will nullify each other and it will not matter. Yeah, so both p-type and n-type are always electrically neutral. Keep that in mind. Next one. The current voltage characteristics of a PN junction are given in forward bias. The ratio of the dynamic resistance around 2 volts and 4 volts are how much? The idea of dynamic resistance is that it is just like voltage is current into resistance. Resistance is voltage by current. So it is change in voltage by the change in current. That is the logic behind it. So in the first scenario, so the resistance dynamically at 2 volts will be change in voltage at 2 volts, which is 0.1, divided by the change in current, which is 5 milli, which is 10 to the power negative 3. So it will go positive 3 and 0.1 will make it 10 to the power 2, I believe, divided by 5, which is 100 by 5, which is 20 ohms, is the dynamic resistance at 2 ohms. At 2 volts. Similarly, using the same formula for dynamic resistance at 4 volts, the change in the voltage is 0.2 volts. For that, how much is the change in current? 15 milliamperes. So 50 into 10 to the power minus 3, which is 2 into 10 to the power 2 divided by 50, which is 200 by 50, which is 4 ohms. Now the question is exactly find the ratio of both of them. So R2 by R4 will be 20 by 4, which is basically 5. Ratio is asked. So ratio will be basically 5:1. That's it. Straightforward answer. Yeah. Everyone able to see me, hear me clearly? Let me know in the chat box, because sometimes the stream might get disconnected and I don't want you guys to suffer on that. Okay. Perfect. Let's go to the next question on your screen. Consider a situation in which the reverse biased current is increases when it is exposed to light. So it is a photodiode basically. When light of small wavelength is incident, during the process, enhancement in carrier concentration takes place due to generation of whole electron pairs, the value of the band gap. So light falls, because of which the electron jumps from the valence band to the conduction band, which increases the conductivity. So that band gap energy, whatever is that gap of that energy, is being provided by the light or the photon which is incident on it. And it is clearly mentioned the photon's wavelength should be less than 621. It's like a cutoff wavelength. So that is hc by lambda, or you can also use 1 to 1240 divided by lambda in nanometers. So just use that 1240 divided by 621. So that is going to give me how much? Roughly 2 electron volt. 124 by 6. T2 is 2. So 2 electron volt should be the answer, which is option D. Yes, option D is the right answer. Clearo? Perfecto? Yeah? Amazing? Very good. Very good. Let's go to the next question coming up on your screen. And here it is. When a PN junction diode is connected in forward bias, its barrier potential. So you have a diode PN, P connected to positive and connected to negative. So this is that junction. Earlier, N will be at lower, P will be at higher. So what will happen, guys, to their barrier potential? Yes, that barrier potential will reduce. Barrier potential, that potential difference whichever was there between P and N. So you will see that it will reduce and eventually you will overcome it and more current will flow in that circuit. Yes, more current will flow and it decreases. So the voltage difference will reduce. The voltage difference, barrier potential will reduce, and that will cause more and more current to flow in the circuit. That's what happens in forward bias. In forward bias. Exactly. B option is absolutely correct, guys. Perfecto. That's amazing. Amazing. Next question. Very nice question. Wow. There is a beautiful circuit given in front of you. And they are asking what is the output of the following circuit. Output is over here. There are two diodes also mentioned. Now, let me tell you, because there is a resistor here, so this 5 volts will drop, and this point, the voltage will be whatever current might be flowing, 5 minus I into whatever is this resistance. Now, because this is at low potential, this is at high potential, 5 is more than 5 minus IR, obviously. So this is high versus this is low potential. So this diode becomes a reverse bias. So the current in this part will be not there. No current will be there. That is one thing which is very obvious now. Next important thing, if you notice this particular part of the circuit, this is grounded, so this is 0 volt. If this is 5 minus IR, so obviously, this is at a higher voltage, this is at a lower voltage. So low potential versus high potential. So definitely current will flow because this will be in forward bias. But it is mentioned that they are ideal diodes. So there will be negligible voltage drop across the diode. So this will still be roughly 0 volt only, maybe 0.1, 0.2, very close to 0, but slightly more than 0. So this 5 minus IR will be also almost 0. So the output will also be 0 because this point, and this point all should be at the same voltage. It's the same wire. So the answer will be 0 volts. Let's check it out. It is right. Yes, it is absolutely correct. So this is how you should solve these kind of questions where you see some resistors and diodes connected in the circuit. Okay. We'll do more questions. Don't worry, where diodes are connected and you have to find current, voltage, etc. Like this one. What is the current shown in this circuit? Now, the positive terminal is connected to P on both sides and negative to N. So both the diodes are forward bias. So 0 volt difference, assuming the diodes are ideal. So now it becomes as if there are two resistors in parallel, which means you connect it as one single resistance with one battery. That's all. So 2020 will become 10 ohms and this is 5 volts. So the current in the circuit will be voltage by resistance, which is nothing but 0.5 amperes. So 0.5 amperes is basically option number 3. Both the diodes were forward bias because P's were connected to the positive of the battery. Then in the next question, something else is happening. These diodes are there, but they are connected in the opposite way. So X and Y, there is a battery which is connected D1 and D2 to normal. If positive is connected to point X, so the positive terminal is connected to point X. plus 5 volt, and this is 0 volt. So what will happen? This diode will become forward, and naturally this diode will not conduct, it will be reverse bias. This current will be zero, no current will flow in this branch. So whatever current has to flow will flow like this, like this, like this, through this diode, like this, like this, and like this. And this current will be the voltage, which is 5, divided by the only single resistance, which is 10. So this will be just 0.5 amperes. This diode will have negligible drop, which we can ignore, assume to be ideal normal silicon diode. So roughly 0.5 amperes is what you should get. Roughly 0.5 amperes is what you should get. But if it is ideal, if this is ideal, but what will happen if it is clearly mentioned in the question itself that, listen bro, it is a silicon diode. A silicon diode has a voltage drop of roughly 0.7 volts. 0.7 volts. So out of the 5 volts, what will happen? 0.7 volts will be dropped here. 0.7 will be dropped here. The remaining 4.3 volts, the remaining 4.3 volts will be across the 10 ohms. So in that case, the current will be voltage divided by the resistance. So that will be 0.43 amperes if it is a silicon diode. So hence 0.43 being in the answer will be C. Although 0.5 is there, that is only for ideal diodes. Ideal diodes, there is negligible drop, but for real diodes, there is a drop which you need to consider in such situations. So there is a small word like silicon here that can change your answer and can give you negative marks. So be very, very careful. Okay? So be very, very careful, guys. Cool? Let's go to the next question on your screen. Here it is. This is current voltage graph for electronic device. Which device do you think it is likely? Current voltage positive, positive? No, everything is negative. So it's in reverse bias, obviously. So if it is this side, voltage is negative means reverse bias. And what is this? This is basically breakdown region. This is breakdown region. Which diode is there which is operated in reverse breakdown region? It is only one diode, and that is none other than your Zener diode. Yes, correcto. Zener diode is the correct answer. Vijay Kumar, I hope I'm audible, visible to all of you. Very good. Very good. Perfect. Perfect. Let's go to the next question on your screen, and here it comes. Zener diode, resistance, ammeter, voltmeter, battery. Zener breakdown is also given. What is the reading by the ammeter? How to solve these kind of questions? See, usually the breakdown voltage will be given, right? So whatever is the breakdown voltage will be actually the voltage between the two ends over here. So for a moment, just like this voltmeter is not even needed. Okay, not even needed. This voltage is exactly 4 volts. This is 4 volts. This is 12 volts. So the remaining 12 minus 4, which is 8, is dropped across this resistance. That is the first thing. There will be always one resistor in series. So 12 is this plus this volts. So if 4 out of 12 is dropped here, the remaining 12 minus 4, 8 volts will be dropped in this resistance. That is the number one thing. Number two, find out the currents. How much is this current? This current will be the total voltage across this divided by the resistance, which is 100. So that will be 0.08 ampere, which is nothing but 80 milliamperes, if I'm not wrong. Yeah, is that right? 80 milliamperes. Current is voltage divided by simple resistance. That's all I have done, nothing else, and we get the thing. Now, what is next? Observe here. What might be the current in this branch and this branch? This current, let's say I call it I1, will be this voltage divided by this resistance. This voltage is 4 because both of them are in parallel, divided by the resistance, which is 400, which is just 1 by 100th of an ampere. So it is basically 10 milliamperes. I don't even need this value. So answer is directly 10. But if at all this is asked how much current is flowing in the Zener diode, then remember I2 amperes, milliamperes plus this current, which is 10 milliamperes, will give me 80. So I2 will be 70 milliamperes through the Zener diode. This is not asked, but if it is asked. Right now only this is given, this is asked, so just give. We don't even need this. Directly voltage divided by resistance is the answer. We don't even need this 8 volts. We know whatever is the breakdown voltage will be over here. So we could have directly given this answer. But I did the extension of it in case this current is asked or this current is asked or this voltage is asked. Okay, in case, but it was not required for this particular question. Okay. So maybe for the next question, it might be required like this one. For the diagram, can you figure out what is the Zener current in this? Zener breakdown is 50 volts. Resistances are given. Standard model of question, guys. First of all, whatever is that voltage, 50 volts will be there both for this resistance and the Zener diode. Next, 50 volts is there here. This is 100. So the remaining 50 volts will be dropped in this resistance. Next, how much is this current going to be? Let's say I call it I1 will be voltage, which is 50 divided by resistance, which is 2000. So this will be in amperes. You multiply it by 1000. 0, 0, 0 will cancel. 50 by 2, which is 25 milliamperes will be here. If you ask me how much is this current will be voltage divided by the resistance. This will be in amperes. If you convert it into milliamperes, multiply by 1000, you will get 50 milliamperes. Now, the last step is very important. So, whatever is that Zener current, if you apply Kirchhoff's current law, input current is nothing but 50. So 50 is branching out as IZ and I1. I1 is 25. So therefore IZ will be also 25 milliamperes. This I am writing it using Kirchhoff's current law. That's all. So 25 milliamperes is option A, of course. That is the answer. These kind of questions, again I am telling, are very, very common. Okay, cool. Let's go to the next question coming up on your screen. Sometimes it can be word-based questions also. Look at it. Zener diode with 5 volt Zener voltage, that means that's the breakdown voltage. You are using it as a voltage regulator for input of 25 volts. 400 ohm resistor is in series. Zener current is found to be 4 times the load current. The load current is IL and load resistance is how much? See, tell you, first of all, draw the circuit without which you will not be able to get the correct answer. So there is 5 volts of battery which is connected over here. This is positive, this is negative. There is a series resistance. Series resistance is 400 ohms. It is in series with this Zener diode. Zener diodes are always connected in reverse bias, note it. And Zener voltage is 25 volts. So, sorry, for Zener voltage is 5 volts, my bad. So, whatever is the voltage across Zener diode, no matter what, will be 5 volts. And you are connecting a load resistance over here. So this is that load resistance like this. I will call it R. And the question is, what is the load current and the load resistance? That's all. That's the question. Simple. Okay. 5 volt is given. 25 volt is given. And Zener current is found to be 4 times the load current. This is also given. Okay. So if this is I, this is given to be 4I. So naturally, this will be 5 times of I. Is that okay? So this will be 5 times of I by Kirchhoff's current law, nothing else. Now, input voltage is 25. Sorry guys, this was not 5, 25. Input is 25. My bad. So out of 25, 5 goes here. How much will be remaining? How much will be remaining over here? Think about it. 25 minus 5, that will be 20 volts. So, can I say current, which is 5I, will be the voltage, which is 20, divided by that resistance, which is 400. Is that right? That is what it will be. So from this, I'm going to get the value of current, of course. 0, 0 cancels. 2 by 40 is 1 by 20. And that 1 by 5 comes over here. So this will be 1 by 100 of an ampere. And milliampere, this will be 10 milliamperes. So 10 milliamperes, that's there only over here. So fourth will be correct answer. But I cannot mark it directly. I will just re-verify it. What about this resistance? So for this resistance, voltage phi is equal to the current, which is 1 by 100 of an ampere into the resistance. So multiply both of them. R will be 500 ohms. That's all. So directly 500 ohms and 10 milliamperes is fourth option. There you go. So these kind of questions is what you are going to get usually in your Zener diode. They will either give the diagram or they will maybe not give the diagram and give it in words. Cool. Then this particular question, guys. In the given circuit, the power rating of the Zener diode is given, the value of the resistance to regulate the voltage. How much will you need? Okay, very nice question. They have asked, they have given the power and they are asking what is the RL value required. See, don't get scared if power is given. Remember, power is nothing but voltage. Power across the Zener is voltage into current across the Zener. So 10 milli means 10 to the power negative 3. Voltage of Zener is 5. So I will get Zener current as 10 by 5, which is 2 milliamperes. So I got this current. I got this current as 2 milliamperes. Number one. Next, if this is 5 volts, this is also 5 volts. Yeah. If this is 5 volts, this is also 5 volts. Agree with this? So what was the question, by the way? What is this value? No? Okay. So for this resistor, 5 volts is whatever is the current across the load into the resistance across the load. So resistance across the load is nothing but 1 kilo. So 10 to the power 3 and this is 5. So IL will be 5 by 10 to the power 3. So that is 5 milliamperes. This is 5, that is 2. If this is 5 and that is 2. So naturally, it is very natural that you can estimate how much will this current be. This will be obviously 5 plus 2, which is 7 milliamperes. Now this 7 milliamperes will be across a voltage of how much? 8 minus 5, which is 3 volts. Out of 8, 5 is dropped here, remaining 3 will be here. So using voltage is equal to current, which is 7 milli into resistance. I will get my resistance. Is that right? This was 8, this was 5. I hope that is correct. So this much is 3 is nothing but this was 2 milliamperes, this was 5 milliamperes. Is that right? 5 milliamperes, correct. Current voltage is 5, resistance is 1. So IL is 5 milliamperes. That one was 2. Power is voltage into current. So current will be 10 by 5, which is 2. Perfect. 2 plus 5, which is 7. Okay. So resistance will be nothing but 3 by 7 multiplied by 10 to the power 3. That's what you are going to get. So which of the following will be correct then? Come on, guys. Which of the following will be correct? Which of the following will be correct? The resistance which is required to regulate it, the resistance which is required to regulate it, it is definitely lesser than 1 kilo ohm. This is basically 3 by 7, which is 0.5 kilo ohm types or lesser than 0.5 kilo ohms types. So guys, what should be the answer? I think if you see, regulate the input. At least this resistance should be there. If I use more than this also, it should be fine. This is the bare minimum resistance, if you think about it. Any resistance slightly more than this will also will it work? Yeah, close enough to 1 kilo ohm will also work. It should not be a problem. But 3 by 7 will be the scenario where 2 milliamperes will go through this diode and 5 milliamperes will go through this diode. Total current will be 7 milliamperes. But if I increase the resistance over here, then the current will reduce, this current will reduce, power will reduce, which is okay. The power rating is 10 milliwatt. So it will consume less power. That's okay, but it will still be better than this. So it can be more than 3 by 7 also. This is like minimum resistance. So if you can use 1 kilo ohm also, it's fine. But 10 ohm will not work. How about 10 kilo ohm and 5 kilo ohm? How about 10 kilo ohm and 5 kilo ohm? Will they work or not work? Think about it. What about that? What about that? What about that? If I keep on increasing the resistance, and what if the diode does not conduct only any electricity and there is negligible power in it? In an extreme scenario, imagine this is the power rating. This is the maximum power that it can take. This was the maximum power that it can take. So this current will also be the maximum current which it can take inside. What will be the minimum current which it can take? I think the minimum current will be 0 amperes. In that case, all the current is going in the outside circuit only. And if all the current is going in the outside circuit and load current is 5 milliamperes, so in such a case, this current will be also 5 milliamperes. Whatever current is here will be here. Negligible current is going inside Zener diode. So in that case, my 3 volts will be current of how much? 3 milliamperes, sorry, 5 milliamperes into the resistance. So the resistance will be 3 by 5 into 10 to the power 3 ohms. 3 by 5 into 10 to the power 3 ohms. Is that right, everyone? 3 by 5 into 10 to the power 3 ohms. So these are the values which I can get of resistance between 3 by 5 to 3 by 7, and I can see none of the resistances are matching with it. So I think the answer should be none of these. Yeah. Then I will mark the answer as none of these, because 1 kilo ohm, 10 kilo ohm, 10 ohms, 5 kilo ohms, none of them are in this range of resistances. Like even when it is not consuming current, no power, versus maximum power it is drawing also, even then the resistances are well beyond these ranges. So I don't think any of them will be working. Okay, clear everyone? Am I audible, visible? I hope not buffering anymore. Oh my god, it's buffering. But now it is fine. Now it is fine, luckily. Let's do logic gates, guys, the last part. Now it's perfect. Okay, perfect. Logic gates, guys. Next, find the logic gate when both inputs are high but the output is low, and vice versa. When both inputs are basically high, okay, when both inputs are high, then the output is low, and when both inputs are low, the output is high. Which gate will be like that? AND gate, OR gate, NAND gate, NOR gate. AND gate, both are high, it should be high. So I think this is opposite of AND gate, because in between what happens, 0, 1, 1, 0, you are going to get this as 1 and 1. So this can only happen for basically a NAND gate. Hence the answer should be option C. Yes, perfect. There you go. All good? Yeah, clear why it is so? Did you understand, guys? Why is the answer a NAND gate? When both inputs are high, output should be low. That happens only in a NAND gate. OR gate also, both are high, it will be high. NOR gate, what about NOR gate? NOR gate also it can happen because 0 and 0 will be 0, but not of it will be 1. 1 and 1 will be 1 or 1 will be still 1, and NOR of it will be 0. So NAND is also possible, even NOR is also possible. But when both inputs are high, the output is low, and vice versa. So actually both options are possible if you think about it. Yeah, even NAND is possible and even NOR is also possible if you think about it, because I did not mention what will happen if one is high, one is low. What is the answer? That is not given in the question statement. So both these options seem to be correct. Is that okay? Next question on your screen. Consider the following logic gate. Output is y equal to 0. When is it going to be 0? Okay, let's think. So if this is 0, there is a NOT gate over here, and before that there should be a 1. That means the output is a high, and for an AND gate the output is high when both of them are 1. So this is also 1, this is also 1. Guys, these are not joined, okay? There is a printing mistake over here. Okay, this is only possible when both inputs are high, then the output will be also high, but because it is a NOT gate, there will be a 0 output. If this is 1, this is also 1, this is also 1. Now for an AND gate, when is the output 1? When both are 1. Is that right? When both are 1. So that means A is also 1, B is also 1, and if over here B is 1, A is 1, not of it is 0, or is okay, 1 or 0 is still 1. So hence A and B both have to be 1. Option C. So I went with the reverse logic, nothing else, and you will get the answer. Cool? No, not possible, sir. For 1, 0, the output will be 0. No, the point is, for the problem over here, nothing has been mentioned. Is it 1 or 0 or 1 or 0? Nothing has been mentioned over here. That is the problem. Because these extremities are only what decides whether it is a, AND gate or an OR gate. Because when both are 0, whether it is OR whether it is AND, answer is 0. When both are 1, the answer is anyways 1, both for AND gate and OR gate. In between, what happens? For OR gate, the answer will be high. For AND gate, the answer will be 0. And exactly opposite for NAND and NOR. But nothing has been mentioned about it. So we cannot for surety say it is NAND or NOR. That is the problem. Okay? Pandit Amelian, I will be doing all chapters from vectors, kinematics, 1D, motion in straight line, basically motion in a plane, relative motion, then circular motion, then Newton's laws, friction, work power energy, then center of mass, momentum, collisions, and rotation. That is your entire kinematics mechanics section, 11th standard. Yeah. Okay. Moving on to the next question coming up on your screen. Which of the following circuits has the same output as of the given circuit over here? Okay, one of them gives me the same output as whatever this circuit is giving. So which of the following is exactly that particular circuit? That is the question. Let's think about it. Okay, let's go one by one. This is A, this is B. So this is A, this is B bar, this is A dot B bar, which is going over here. This is, as it is A, this is B. So this is A dot B. There is an OR gate over here. So the output Y will be A. Should have been A dot B bar. A dot B bar. Sorry, it was like that. Yeah. So the output will be A dot B bar plus, because it's an OR gate, plus A dot B. Now there is a symbol like circle over here. That means it is a NOT operation. So I should put a complete bar over it. That is the idea behind this equation. Now what I can do, I can take that common bar is there. A is common. So I can put A dot B bar plus B over here. Now what is the meaning of A dot B bar plus B? What is B bar plus B? Answer is simple. If you consider B bar plus B, right? If B is 0, this is 1. If B is 1, this is 0. And 0 plus 1 is always 1. So no matter what you do, this bracket term will always be 1. Now A dot 1 is always going to be A. A dot 1 is always going to be A. So this is A bar. So this is as good as saying not of A. Not of A. So how do you do not of A? A is there. This is basically a NOT gate. If a NAND gate has been shorted, it becomes a NOT gate. This is a NOT operation. So answer should be 1. That's it. So if you do it by truth table, you will waste a lot of time. If you do it by Boolean algebra, like this, it becomes very simple and easy. You will be very convinced. Otherwise, you are always confused whether you have missed any case, or is my truth table correct or wrong, and all of that. Okay. So whenever you see this, remember NAND gate with same terminals, it is as good as a NOT gate. This is A and this is Y. This is a NOT of A. Right. Moving on to the next question. Identify the circuit over here. Identify the circuit over here. Okay. So this is A, this is A bar, this is B, this is B bar, this is ANDing operation. So Y is nothing but A bar, B bar dot. So A bar, B bar dot, so I can put, and there is a NOT gate also, sorry, NOT gate also. So I can do one thing, I can take A bar, B bar separate, I can separate out those common bar, and this dot will now become plus. This is called De Morgan's theorem. So whenever there is a dot, it becomes plus. Whenever there is a plus, it becomes a dot. And that common bar will be separated out. A bar bar, negation of negation is the same thing. Negation of B 2 times is the same thing. So A plus B is basically a OR gate. Hence, the answer will be option number 2. Got it? Everyone? Perfecto? Kudos, guys. Kudos to all of you. Amazing. Let's go to the next question. Wow, truth table based. Which of the following truth table is the correct representation of A and B? What do you think? Function of A and B, yeah, over here. Take anything and see one by one. Let's say this is 0. Let's say this is 0. This is also 0. 0 and 0 is 0. 0 will come here. B will become 1. 0 or 1 will become 1. So output should be 1. And that is only happening in this case. No other case. So answer should be 2. I mean, I don't even have to check others. If I check also, I'll get the same thing. But luckily for us, there was only one option which said 0 and 0 is 1. I don't have to do anything else. Isn't that fascinating? Unnecessarily, sometimes people think, oh, sir, it is going to be a time consuming problem, but actually it is not. Okay, let's do this. What is the final operation? Whenever I see these things, I understand that actually it is a NOT operation. This is also a NOT operation. This is a NOR operation. Okay, let's think. If this is A, this will be NOT of A. This will be NOT of B. This is OR operation. So A, B, OR. But there is a circle, so common bar. Use De Morgan. So A bar is there, B bar is there. Plus will become dot. And the common bar will separate. Negation of negation is the same thing. So A dot B as it is. So A dot B means it is a AND gate. That is the correct answer. Yeah, simple. Option number 2. Perfect. Very good. Very good. Very good. Excellent. Let's go to the next question, guys. A very similar question. This also you can do it now. It's the same thing. Similar things. Guys, first of all, this is a NOT gate. This is OR plus a NOT gate. Now these two NOT gates together, they will end up cancelling each other out. This is also a NOT gate and this is also a NOT gate. That's it. Now it becomes easy to solve. If this is A, this is A bar. If this is B, this is B bar. And this is just a simple OR gate. So it is A bar plus B bar. This is just A bar plus B bar, simply put. So this can happen when you have A dot B common bar. This is De Morgan's principle. Plus becomes dot. And now the separate bars will become a common bar. What is this? This is AND with a NOT. So this will become a NAND gate. Is that right? So this will become a NAND gate. Simple. Option C. Everyone? Pakka? Absolutely. Very good. So I think you will be able to solve this question also now. Because you can see this is actually a NOT gate. This is AND gate with a NOT gate. And two NOTs will always end up cancelling each other. This is also a NOT gate. This is also a NOT gate. Whenever you connect the two terminals, it becomes a NOT gate. So this is A, this is A bar. If this is B, this is B bar. And you just have a AND gate as the output. So it is A bar dot B bar. You can write it as A plus B with a common bar. That's it. This is De Morgan's principle. So A plus B whole bar is a NOR gate, of course. Yeah, that is option A. Cool, guys? Perfect. Amazing. Yes or no? Cool. Let's go to another question coming up on your screen. What is the final circuit going to be? XOR, NOR, NAND, AND. Now, I don't think it will be NAND, AND, or NOR. Most likely it will be A, but still we'll do it. So this is better done by truth table because I want to explain you what is this XOR in case some of you might not know it. Take all possible combinations. Say this is 0, this is 0. So 0, 0, this will be 0, this will be 0. 0 and 0 is 0, not of it is 1. 0 or 0 is 0. So 0 will come here, 1 and 0 will be 0. So output will be 0. Very simple. Okay. Then try out. This is 0, this is 1. Let's say this is 0 and this is 1. So this will be 0, this will be 1, this will be 0, this will be 1. Okay, see what will happen. 0 or 1 is 1, 0 and 1 is 0, not of it will be 1. So 1 will go over here, 1 will go over here, 1 and 1 will be 1. So the answer will be 1. Is that right? Same logic. Now apply like this. This is 1, this is 0. So 1 and 0. Same 1 will come here and here. This 0 will go here and here. 0 and 1 is 0, but not of it will be 1. So same 1 here. 0 or 1 is 1. Same 1 will go here. 1 and 1 will be 1. So this will be also 1. Lastly, see this. It's not taking too much time. Just have to do it. This is 1 and this is also 1. 1, 1, 1, 1, 1, 1. 1 and 1, 1. Not of it 0. Now, doesn't matter what comes here, answer will always be a 0 because 0 and anything will be a 0. This is exclusive OR, meaning only when the inputs are distinct, the answer is a high or a true or a 1. When they are same, then the output is a low or a 0. This kind of gate is called as a XOR gate, exclusive OR. Exclusively, they are opposite or odd. This or this, both can't be the same. That is exclusive OR. Okay, so that is the answer for that. So that was the last question for today. And yeah, we have taken the marathon for good 6.5 hours. And I hope you enjoyed this marathon. So many questions. It was crazy amount of questions, guys, that we have solved, which otherwise you would not have solved. Honestly, tell me in the chat box or in the comment section. Would you have sat for 6.5 hours or 6 hours and actually done 120, 150, 130 questions? No. Now, I'm pretty sure you are feeling super confident about many chapters from modern physics, and you also know which chapters, which topics you need to revise. Some formulas you would have seen it first time or you would have forgotten. You're going to go back and finish it off. I'll see you again for mechanics on Thursday. Okay? Till then, bye bye. Have a great time. This was Captain Shreyas. Thank you for liking. PDF will be available after some time. And yes, do not forget that you can use Ved AI for asking any doubts, for asking any questions. Yeah, just click on this particular link over here. Ask Ved any doubts. If you have not yet logged in, please log in. It's a free account. You can ask doubts. Description will have the quizzes, your smart notes, and my actual notes over here. And of course, you can ask doubts to Ved free of cost. Ved subscription is free. Only you have to be a Vedantu user in any way, either in a batch or not in a batch, or even if you're just having an account, freely account you have created, like you create Gmail account, Instagram account, which is free, same way you can use it. Okay, so this is our amazing friend who is not artificially intelligent, but I feel it is super intelligent. So make use of Ved for your benefit, especially during this exam time. Okay, so have a great time, and what a lovely session. Take care, guys. Bye bye. See you.